everyone, welcome back to another Study Live session. Hope you all had an amazing day and a good one, productive one too. With that being said, without any more further ado, let's get started. I'll be doing zoology and this is breathing and exchange of gases. Yeah. With that being said, grab up your books and all the study materials or whatever you require, whichever subject you're doing, let me know. And yep, let's get started. Okay, this book which I'm referring is Biology Notes, Human Physiology 1 by Dr. Neela Bakore. Let's get started. Breathing and exchange of gases. Respiration is a catabolic process which involves exchange of gases and utilization of oxygen to break down food to release energy. Oxygen monomerase energy. It is a physiochemical process. Okay. Respiration is completed in three stages: breathing or ventilation, exchange of gases at lung level, and transport of gases by blood. Exchange of gases at tissue level or cellular respiration. Breathing or ventilation, exchange of gases at lung level, and transport of gases by blood. Exchange of gases at tissue level or cellular respiration. Types of respiration: aerobic and anaerobic. Aerobic respiration in the presence of oxygen, anaerobic respiration in the absence of oxygen. Example: muscle cells. Direct or indirect respiration. Direct change of gases, exchange of gases between cells and water. No blood for circulation. Moist surface for exchange of gases. Example: amoeba and sponges. Indirect, no direct contact between body cells and atmosphere. Circulating medium is needed. Specialized organs found. Examples: through gills in fish, prawns, through skins in annelids and amphibians, through lungs in males, some amphibians, all reptiles, birds and mammals. Characteristics of respiratory surface: must be thin, moist, mucous membrane, highly vascular, richly supplied with blood vessels, highly permeable to respiratory gases, large surface area for great exchange. Respiratory pigments increase the rate of diffusion. Organs for respiration: skin, cutaneous respiration, examples earthworm, frog; trachea respiration, example insects; gill, branchial respiration, example fishes; some crustaceans, are prawn; gill; lungs, pulmonary respiration, example amphibians, reptiles, birds, mammals; book lungs, example scorpions, spiders; pulmonary sac modified mantle, example mollusks; book gills, example aquatic arachnids, lemurres; dermal branchiae, examples echinoderms; pouch gills, example agnathans, cyclosomes. Respiratory pigments: hemoglobin, when oxygenated, its color is red. Invertebrates, it's found in RBC. In invertebrates, it's found in blood plasma. Metal base is ferrous iron. Chlorochlorine, the color is green. When oxygenated, the color is red. Found in annelida. Example, Sabella metal. Metal base is iron. Hemoerythrin, it is colorless. When oxygenated, the color is red or brown. Found in annelid. Metal base is iron. Hemocyanin, the color is green. When oxygenated, the color is blue. Metal base is copper. Found in phylum Arthropoda except insects, and it is also found in mollusks. Echinochrome, color is red. Metal base is iron. Found in Echinodermata. Vanadium, metal found in vanadium. Found in stellonic fluid of protochordals. Hemoglobin, metal found in manganese. Brown pigment, example mollusk, Sina. Cutaneous respiration, examples earthworm, frog. Skin is kept moist by mucous glands. Skin is highly vascular. When earthworms O2 diffused into blood binds with hemoglobin, which is dissolved in plasma to form oxyhemoglobin. Oxyhemoglobin releases O2 at tissue level due to low concentration of O2 and high concentration of CO2 in the tissues. Hemoglobin due to low concentration of O2 and high concentration of CO2. Earthworms respire through their skin in air as well as water. If O2 is not available, they die due to Asphyxiation, photostarvation. Asphyxiation is photostarvation. Frogs respire through skin, through buccopharyngeal membrane, mucous membrane of buccal cavity and pharynx, through lungs when on land. Asphyxiation. Tracheal respiration. In this type of respiration, the respiratory organs are ectodermal and highly branched air tubes called trachea. This type of respiration is found in insects, centipedes, millipedes, some spiders. Tracheal respiration is well developed in these organisms because body wall skin is thick with exoskeleton and impervious to gases. Blood is colorless without any respiratory pigment. The fluid is called hemolymph and has no role in respiration. Tracheal respiration in cockroach. The tracheal system opens outside by spiracles, stigmatum, 10 pairs of sparacles on lateral walls, 2 in thorax and 8 abdominal segments. Last two segments do not have sparacles. Sparacles have valves to regulate openings and closing and bristles for filtration. First thoracic spiracle and first abdominal spiracle remain open all the time, but other thoracic and abdominal spiracles open and close. Spiracles open into ampulla and then into lateral tracheal tube. Trachea is lined by chitin material called erythema. Erythema has spiral thickening called AVD. Trachea divides into tracheals and terminal tracheals. Tracheals have thickening of chitin, another chitin substance which prevents it from collapsing. In insects, the muscles responsible for respiration are abdominal muscles, sternal muscles. When these muscles contract, the volume of the body cavity decreases and the pressure increases. As a result, the air from trachea flows out. When the muscles relax, the body volume increases and the air is drawn in. That is, in insects, inspiration is passive and expiration is active. Terminal tracheoles are filled with tracheolar fluid. At rest, the tracheolar fluid fills the complete tracheal tubes and reaches up to the sparacles. Oxygen dissolves in the tracheolar fluid and gets diffused to the cells. In insects like housefly and honeybees, tracheal system has air sacs to store air. Bronchial respiration. In this, the organs of respiration are gills. It is characteristic of aquatic animals like most crustaceans. Crustaceans are prawns. Some mollusks, bivalve, fishes, and tadpoles. These animals have developed certain adaptations to use oxygen dissolved in water efficiently, as water is 800 times denser. Water contains about 1 by 38 of O2% in air. The rate of diffusion is 5 lakh times lower in water as compared to air. The adaptations are counter current mechanism. Blood in the capillaries of the gills flow in the opposite direction to the flow of water. Continuous one-way flow. Rapid and continuous water flow from the respiratory surface to the gills to increase the rate of diffusion. Counter current exchange, concurrent exchange. Types of gills on the basis of position. Okay, external and internal are external outside the body, uncovered, visible externally. Example: some annelids, insects, larvae, target flight. Internal inside the body, uncovered in cartilaginous fishes, covered by operculum. On the basis of attachment, podobranches, foot gills, attach on appendages, extrabranches, branches. Frogs have 8 pair gills. Pulmonary respiration. In this type of In this type, the respiratory organs are lungs. It is found in some snails, amphibians called reptiles, birds, and mammals. The main reason for development of pulmonary respiration are skin is thick and impermeable. They have highly metabolic rates, so O2 requirement is high, and so they need an extensive surface area for respiration. Lungs have approximately 750 million alveoli and provide 100 square meter of surface for exchanges compared to 1.6 square meter of skin. So lungs are 50 times more efficient than skin. Respiratory system in humans. The parts of human respiratory system are respiratory tract, respiratory organs, diaphragm. Respiratory tract, nostrils or external nares. Nasal chamber. These are two large capsules present over the palate and are separated by nasal septum. Each nasal chamber has three parts. Vestibular part. It is anterior small chamber lined by hairy cells and mucus to prevent the entry of dust particles. It acts as filtration compartment. Respiratory part. It is the middle part and is lined by glandular and vascular epithelium. It acts as air conditioner. Vestibular part, respiratory part. When warm air enters, the mucus evaporates to create the cooling effect. When cold air enters, heat from the blood vessels is radiated into the chamber to warm the air. Olfactory part. It is the posterior part lined by sensory olfactory epithelium. Scammidarian membrane. It helps in perceiving sense of smell. The nasal chamber has three pairs of scroll-like projections called concha or terminal. The three niche membrane, inferior concha or maximal terminal. Concave increase the surface area of nasal chamber for better air conditioning. Function of nasal chamber: filtration, warming, cooling, moistening, sterilizing, smelling. Internal nares, a pair of the roof of nasopharynx. They get closed by ulva. Extensions of soft palate during swallowing. Laryngopharynx. Pharynx. Lower part of pharynx has a slit-like opening called glottis, which is closed by epiglottis bilobe cartilage during swallowing. Laryngopharynx. Larynx. It is also known as voice box or Adam's apple, Thomas Adam. It is more developed in males. It has four cartilages, one cricoid, one thyroid, two arterioles. One cricoid, one thyroid, two arterioles. Cricoid and non-arterioles. Thyroid cartilage is largest and C-shaped. It supports anterior and lateral sides of the upper part of larynx. The anterior part of thyroid cartilage gives rise to bilobed cartilaginous processes called epiglottis, which closes the glottis during swallowing. Cricoid cartilage is ring-shaped and completely supports the lower part of larynx. Arytenoid cartilages are smallest and pyramid-shaped and support the posterior wall of the upper part of larynx. Internally, the larynx is lined by stratified columnar ciliated muscles epithelium, mucous epithelium. Cilia beat outward to eject unwanted particles. Larynx has membranous folds which extend between thyroid and arytenoid cartilages. These folds are called vocal cords. They vibrate to produce sounds. Vocal cords are flaps containing elastic fibers. Vocal cords are longer, 2.5 cm males, and shorter, 1.7 cm in females. Each vocal cord is covered by stratified squamous epithelium. Between two vocal cords is a slit-like glottis. Working of larynx or sound production. Vocal cords can be stretched or relaxed, and the size of glottis can be changed with the help of larynx muscles. During sound production, after normal inspiration, the laryngeal muscles contract as a result. Vocal cords come closer and glottis size is decreased. During exhalation, the air pressure behind the vocal cords increases, which causes them to vibrate and sound is produced. Trachea. It is a 10 to 11 centimeter long tube which runs downwards through the neck and front of esophagus. Thin wall and is lined with pseudostratified ciliated epithelium with mucus secreting goblet cells. Cilia help in expelling dust particles. It is supported by 16 to 20 C-shaped cartilaginous rings which are dorsally incomplete. Primary bronchi. Trachea divides into left and right bronchi. Right bronchi is 2.5 cm longer, wider, shorter, and more vertically placed than the left bronchus, which is 5 cm long. Bronchi are also supported by cartilaginous rings. Primary bronchi enter into lungs through hilus and forms bronchial intercom. Secondary and tertiary bronchi. Right primary bronchus divides into three secondary bronchi, each going to the three lobes of the right lung. Left primary bronchus divides into two secondary bronchi going into the two lobes of the left lung. There are 10 tertiary bronchi in the right lung and 8 in the left lung. Tracheal rings are found up to the tertiary bronchi. Tracheal rings are found up to tertiary bronchi. Respiratory organs, lungs. Lungs are a pair of soft, elastic, and spongy organs. Lungs are slightly conical in shape and are located in pleural cavity in thorax chest on either side of heart. They have narrow apex and broad base. Their outer surface is called costal, posterior surface is called diaphragmatic, and the inner surface is called mediastinal. Each lung is surrounded by a double membrane called pleural membrane. The inner layer of pleural membrane is called visceral membrane and the outer one is called parietal membrane. Between the two layers, pleural fluid is filled. Pleural fluid performs three functions. Lubrication allows frictionless movements of lungs. Protection from mechanical shocks keeps the two membranes together when the lungs expand. The left and the right lungs are not identical. Left lung smaller, right lung bigger. Has two lobes, superior and inferior. Has three lobes, superior, middle and inferior. Right. Weighs 560 grams, weighs 620 grams. Has cardiac notch on the inner surface to accommodate heart. Has no cardiac notch. About 750 million alveoli found in two lungs. Total skin surface is about 1.6 square meter. Total alveolar area is about 100 square meters, that is more than 50 tons of skin, so lungs are better replacement for cutaneous respiration. Each alveolar sac contains 6 to 8 alveoli. Bronchioles about 1 millimeter in diameter are the largest air passages without cartilaginous support. Terminal bronchioles are lined by non-glandular ciliated columnar epithelium to avoid any blockages of mucus. Alveoli are lined by lecithin. Lecithin acts as a surfactant, reduces surface tension and prevents them from collapsing. In rabbits, the left lung has two lobes. Rabbits. Lungs. This is lungs. Trachea, primary bronchus, secondary bronchus, tertiary bronchus, bronchioles, terminal bronchioles, respiratory bronchus, alveolar duct, alveolar sac, atrium, infundibulum. Diaphragm. It is characteristic of mammals. It is highly muscular and dome-shaped. It separates thoracic and abdominal cavities. Respiratory or pulmonary volumes and lung capacities. Spirometry is the process of recording the changes in the volume of air moving in and out of lungs. The instrument used is called spirometer or respirometer. The graph showing these changes is called spirogram. All pulmonary volumes are 20 to 25% less in females and more in men, athletes, people living at higher altitudes, and divers. Tidal volume TB. It is the volume of air inspired or expired with each normal breath. It amounts up to 500 ml in average adult. Out of this 500 ml, only 350 ml reaches the alveolar and is called alveolar volume. The remaining 150 ml remains in the respiratory tract from nasal chamber to terminal bronchus, which is called anatomical dead space and is called dead space volume. Physiological dead space includes anatomical dead space, and the space is the non-functional alveolar. Respiratory reserve volume. It is the extra volume of air which can be forcefully inhaled beyond normal tidal volume. The extra volume of air inhaled by normal tidal volume. is about 2000 to 3000 ml. Inspiratory capacity IC. It is the amount of air which can be inhaled to the maximum level. It is the sum of TB and IRB, and it is about 2500 to 3500 ml. Expiratory reserve volume. It is the volume of air that can be forcefully expired after a normal tidal expiration. It is about 1000 to 1500 ml, average volume 10 ml. Vital capacity. It is the maximum amount of air that can be expired from the lungs by forceful exhalation after a forceful inhalation. It is the sum of total of tidal volume, inspiratory reserve volume, and expiratory reserve volume. TVIRB plus ERB is 500 plus 2000 to 3000 plus 1100 gives a prox of 3600 to 4600 ml. Range of vital capacity is 3600 to 4600 ml in a normal adult. VC is higher in athletes, mountain dwellers, young people, men, and divers. Residual volume RV. It is the volume of air still present in the lungs even after most forceful expiration. It is about 1500 ml. This volume of air can never be expelled by exhalation. As this volume is always present in the lungs, gaseous exchange continues even at the end of expiration. Functional residual volume FRV. It is the amount of air left in the lungs after normal exhalation. It is equal to the sum of ERV plus RV. It is about 2500 ml. Total lung capacity TLC. It is the amount of air present in the lungs and respiratory passage after maximum inhalation. It is equal to the sum of BC plus RV. It is about 5 to 6 liters, average 5800 ml. Minute respiratories or minute respiratory volume. It is the total amount of air that moves into the respiratory system per minute. It is equal to product of tidal volume and respiratory rate. TB is 500 ml, respiratory rate is 12 times per minute. Minute respiratory volume equals to 500 into 12, which is about 6000. Minimal air volume. It is the amount of air in collapsed lungs. Alveolar ventilation. It is the rate at which the fresh air reaches the alveoli per minute. It is calculated as rate of respiration into TB minus dead space volume. It is about 4200 ml. Mechanisms of respiration, which is breathing. It involves contraction and relaxation of the muscles of chest cavity called respiratory movements. One respiration cycle is completed in 5 seconds, 2 seconds for inspiration and 2 to 3 seconds for exhalation. Breathing is completed in two phases, inspiration or inhalation, expiration or exhalation. Inhalation or inspiration process. It is an active process. Inhalation occurs when intrapulmonary pressure is less than the atmospheric pressure, that is, there is negative pressure in the lungs. Two pairs of lungs are involved, phrenic or radial muscle. They extend from diaphragm to ribs and vertebral column. Their contraction flattens the diaphragm, thoracic cavity increases. These are the principal inspiratory muscles. These are muscles responsible for 75% of tidal volume. External intercostal muscles. Found between ribs, 11 pairs of muscles between 12 pairs of ribs. Their contraction results in the movement of ribs upward and outward. This increases the volume of thoracic cavity, dorsoventrally and laterally. When these two muscles contract, the volume of chest cavity increases and the intrapulmonary pressure decreases up to -2 to -6 mm. As a result, air from outside rushes into the lungs. Expiration or exhalation. Exhalation takes place when the intrapulmonary pressure is higher than the atmospheric pressure. It is a passive process. When the phrenic and external intercostal muscles relax, the volume of chest cavity is reduced. As a result, intrapulmonary pressure increases and the air rushes out. Forceful expiration. When expiration. When the air is expelled out forcefully after a normal expiration, two muscles are involved, abdominal muscles. They extend from the ribs to the abdominal organs. Contraction of these muscles pulls the abdominal organs upwards. This makes the diaphragm more concave and the volume of thoracic cavity decreases. Antero-posterior. As the volume decreases, the intrapulmonary pressure increases and the air rushes out to the lower pressure. Internal intercostal muscles. They are 11 pair of muscles on and between ribs. When these muscles contract, the ribs upward, backward, and inward. As a result, the volume of thoracic cavity decreases dorsoventrally and laterally. Pressure in lungs is increased by 3 millimeters to 4 millimeters. And exchange of gases. Exchange of respiratory gases takes place by diffusion at two places. At lung level between lungs and blood, at tissue level between blood and tissues. Gases diffuse from the higher partial pressure to lower. The rate of diffusion depends on factors like concentration, gradient, thickness of membrane, and solubility of gases. Partial pressure. Pressure exerted by a gas in a mixture of gases is respective of other gases. Atmospheric 159 atmospheric oxygen, and alveolar 104, blood deoxygenated 40, blood oxygenated 95. Tissues 20 to 40. Atmospheric 0.3, alveoli 40, blood deoxygenated only 46. Blood oxygenated 40. Tissues 50. P of gas is given in the table, or partial pressure of the gas is given in the table, clearly indicates concentration gradient of oxygen from alveoli to blood and from blood to tissues. The solubility of CO2 is 20 to 25 times higher than that of O2, so the amount of CO2 that can be diffused in through the diffusion membrane is much higher than O2. The diffusion membrane is made up of three layers: thin squamous epithelium of alveoli, endothelium alveolar capillary, basement membrane. Gaseous exchange of lung level pulmonary gaseous exchange external respiration. The PO2 in alveolar air is 104 mm of Hg, while PO2 in the venous blood of pulmonary arterial capillaries is 40 mm of Hg. The venous blood of pulmonary arterial capillaries is 40 mm of Hg. The initial pressure difference, which is responsible for diffusion, is 64 mm of Hg. As oxygen diffuses from alveoli to blood, PO2 in blood increases to 95 mm of Hg. Percentage saturation at hemoglobin is 97 to 98%. Partial carbon dioxide of venous blood entering pulmonary capillaries is 46 mm of Hg, while with that of alveolar air is 40 mm of Hg. The pressure difference responsible for diffusion is 66 mm of Hg. After the gaseous exchange, the blood becomes oxygenated and has PO2 and has 95 mm of Hg, and PCO2 has 40 mm of Hg. Gaseous exchange at tissue level, internal respiration. Oxygenated blood is carried from lungs to heart by pulmonary veins, and from the heart to the tissues body passed by aorta. At tissue level, PO2 favors dissociation of hemoglobin present in the blood to release oxygen. This is called unloading of oxygen. Arterial blood has higher PO2, 95 mm of Hg, is compared to PO2 in tissues, 20 mm of Hg. So oxygen diffuses from the blood to tissues. At tissue level, PCO2 is high, about 55 mm of Hg, while in aerial blood it is low, about 40 mm of Hg. CO2 from the tissues diffuse into blood. The increase in PCO2 in blood to about 46 mm of Hg, this is called loading of CO2 of what solid. Coefficient of utilization, percent of oxygen used by the tissues is 25% as venous blood has 75% saturation of hemoglobin. Transport of gases, transport of oxygen as oxyhemoglobin 97 to 99% of oxygen is transported as oxyhemoglobin. Oxyhemoglobin is temporary complex formation of oxyhemoglobin. Oxyhemoglobin is called loading. Oxyhemoglobin dissociate when PO2 is low and PCO2 is high. This condition is found in tissues. Hemoglobin Hb molecules can carry up to 7 oxygen molecules. One gram of hemoglobin can bind with 1.34 ml of oxygen. As dissolved oxygen, 1 to 3% of oxygen is transported as dissolved oxygen in plasma. Transport of carbon dioxide or dissolved oxygen 1 to 3%. Transport of carbon dioxide delta S. Carbonic acid transportation in plasma carbonic acid. As carbaminohemoglobin, 23% of CO2 is transported as carbaminohemoglobin. Carbaminohemoglobin is also a temporary complex which dissociates at high PO2 haldane acids. As bicarbonate ions, 70% of CO2 is transported as bicarbonate ions. CO2 diffuses into RBC. CO2 reacts with water to form chloroformic or carbonic acid in the presence of carbonic anhydrous enzyme. Carbonic and dissociates into H plus and HNO3 minus ions. HO3 minus diffuses into HCO3 minus diffuses out into the plasma. To maintain the acid-base equilibrium, to replace HCO3 minus ions, Cl minus ions enter in a RBC. This is called chloride shift or hamburger shift. Chloride shift, shifting of Cl minus from plasma to RBC. Okay. Oxygen dissociation curve. When percentage saturation, when percentage of saturation of hemoglobin with oxygen is plotted against P over the pH. The curve shows that there is progressive increase in the present saturation of hemoglobin with the increase in PO2. 30% saturation at 20 PO2, 75% saturation at 40 PO2, 97% saturation at 95 PO2. So a normal oxygen dissociation curve is sigmoid, high PO2, low PCO2, low H plus hemoglobin. All these conditions, low force and high force, high H plus concentration and low temperature favor formation for conditions and for in a nutshell. highly PO2 and high PCO2, low H plus concentration, low PO2 and high PCO2, high H plus concentration. Concentration and low temperature favor formation of oxyhemoglobin. High temperature favor dissociation of oxyhemoglobin. All these conditions exist at the tissue level. A high PCO2, higher H plus, higher temperature and low pH acidic. The oxygen dissociation curve turns to right. That is, these conditions favor dissociation of oxyhemoglobin. 100 ml of oxygenated blood can deliver about 5 ml of O2 to the tissues under normal physical conditions. Bohr's effects. The human capacity of hemoglobins is lower with increase in PCO2 and the oxygen dissociation curve turns to right, or higher concentration of CO2 stimulates oxygen dissociation of oxygen. Haldane effect. The reasons for the CO2 is oxyhemoglobin behaves as a strong acid. As more and more oxyhemoglobin is formed, oxyhemoglobin behaves strong acid and it keeps on forming. Respiratory rhythm. Through controlling, though controls breathing is a controlling involuntary process, respiration takes place and is regulated by two controls. Nervous control. Respiratory rhythm center is located in medulla region. Here are the basic rhythms. Basic rhythm of respiration is regulated by three respiratory centers, rhythmic centers. Inspiratory center located in medulla oblongata and stimulates inspiratory muscles and controls normal rhythm for respiration. Expiratory centers lies in the medulla oblongata and remains dormant during normal respiration. It controls powerful contraction of expiratory muscles during exercise. Hemotaxic center lies in pons varoni. When stimulated, it increases the rate of respiration and reduces the duration of inspiration and decreases the depth of respiration, panting effect in dogs. Chemical control. Chemosensitive area is located near the respiratory rhythm center. It is highly sensitive to CO2 concentration and H plus emission. Accumulation of CO2 results in formation of carbonic acid. Carbonic acid dissociates and results in increased concentration of H+, which lowers the pH. The condition is called acidosis. Chemical control. Chemosensitive area is located near our respiratory rhythm center. It is highly sensitive to CO2 concentration and H plus ion concentration. Accumulation of CO2 results in formation of carbonic acid. Carbonic acid dissociates and results in the increased concentration of H plus. Lowers the pH. The pH is called acidosis. Change in PCO2 stimulates chemoreceptors, carotid and aortic bodies located on carotid artery and aorta. This increases the rate of respiration and helps in removal of excess O2. Respiratory centers, CO2. Respiratory centers are at very less sensitive to oxygen. So the role of oxygen in the regulation of respiratory rhythm center is insufficient and insignificant. Some respiratory disorders, infectious respiratory disorders, TB, tuberculosis, diphtheria caused by pertussis, pneumonia, caused by bacterium Dipococcus, also called Streptococcus, pneumonia. Symptoms: collection of lymph and mucus in bronchioles and alveoli. Treatment: antibiotics, penicillin. Bacteria, okay. Influenza flu caused by myxovirus influenzae. It is pandemic disease. Symptoms: bronchitis, sneezing, coughing. Obstructive respiratory disorders. Allergies. It is hypersensitivity of a person to some foreign substance called allergen. Types of allergens: dust, pollen. Allergy to pollen is known as hay fever. Spores, fur, food, drugs, etc. Mechanisms involves steps: uh, sensitization, second stimulation, histamine action. Sensitization in the allergen acts as a mild agent antigen and stimulates formation of antibodies which bind to the mast cells. Second stimulation, allergens combine with antibody bound mast cells which rupture to release histamine. Symptoms: inflammation of mucous membranes, sneezing, running nose, and irritation in throat, rashes, itching, etc. Treatment: antihistaminic drugs. A systematic allergic reaction affecting all body tissues organ, which may it may be due to bee sting or some drugs like penicillin. Anaphylactic shock. Asthma is characterized by narrowing of bronchospasm. It is difficulty in breathing causing wheezing due to inflammation of bronchi or bronchioles. Bronchitis, inflammation of bronchi. Symptoms include coughing, shortness of breath, and welling sound walls breathing. Bronchitis, inflammation of bronchi. Symptoms include coughing, shortness of breath, and wheezing and sound waves, etc. Bronchitis, inflammation of bronchi. Symptoms include coughing, shortness of breath, and wheezing sound with muscle breathing. Emphysema, main cause is cigarette smoking, which inactivates some antiproteinase enzymes which damage interstitial proteins like elastin. This decreases respiratory capacity. Emphysema is characterized by inflammation of alveoli and rupturing of alveoli cells, decreasing the surface area for gaseous exchange. Occupational respiratory disorders. People working in certain industries get exposed to dust particles or fine powder or fine lint which their defense mechanisms cannot fight with. Long exposure to such substances can also lead to inflammation leading to fibrosis, causing long serious lung damage. As only the people working in these industries get affected, it is called occupational disease. Interesting facts. excretory products and their elimination. Excretion is a process of removal of non-gaseous nitrogenous waste like ammonia, urea, uric acid, etc., along with excess of water and salt and pigments. The main aim of excretion is to maintain a constant internal chemical composition called homeostasis. There can be three modes of excretion on the basis of nature of nitrogenous product. Ammonotelism. In this type of main nitrogenous end product is ammonia. The animals showing ammonotelism are known as ammonotelic. Ammonia is the basic catabolism nitrogenous waste formed by oxidative deamination of harmful AAS and the reversals in the presence of an enzyme called oxidase. Ammonia is highly toxic because of its pH. It must be expelled as soon as it is formed. For elimination of 1 gram of ammonia, about 3,300 to 500 ml of water is needed. To ammonotelism is mainly found in aquatic animals. It is found in protozoans, sponges, ciliates, crustaceans, echinoderms, bony fishes, and aquatic larvae of amphibians, tadpoles, and some aquatic amphibians like salamanders. Up to ciliates, ammonia is lost through their body surface. In bony fishes, ammonia is lost as ammonium, iron, through gills and urine. Aquatic amphibians excrete ammonia in urine. Ureotelism. The main nitrogenous waste is urea. The animals showing ureotelism are called ureotelic. Urea is formed in the liver cells and mitochondria by detoxification of ammonia by ornithine cycle of urea cycle. In elasmobranchs, urea is formed by all the body tissue except brain and heart. Urea is less toxic, a lakh times less than ammonia, and so can be stored in the body for some less time without causing damage to the body. It is moderately soluble in water. To eliminate 1 gram of urea, about 50 ml of water is needed. Adaptation for terrestrial mode of life. It is generally found in animals which can retain considerable amount of urea for hypertonicity in their blood and other body fluids. Ureotelism is common in humans and all other mammals, including aquatic mammals like whales, seals, etc. Desert mammals like camel, kangaroo, rats. It is also seen in terrestrial shark and semi-aquatic amphibians, frog, toads, etc. Cartilaginous fishes, elasmobranch sharks, rays, etc. In man, urea accounts for 80 to 90% of total nitrogenous waste. Uricotelism. The main nitrogenous waste is uric acid. The animals showing uricotelism are called uricotelic. It is formed from the initially in the purines, adenine, and guanine, mainly in the liver, slightly in kidneys. Urines change to xanthine, which into uric acid. Adenine or guanine, xanthine, uric acid. In human beings, the main source of uric acid are purines, though the main nitrogenous waste is urea. It is least soluble in water. About 10 ml of water is needed to expel 1 gram of uric acid. Uric acid is least toxic, so it can be stored in the body for a long period of time without causing any ill effects on the tissue. Excretion of uric acid is a greater advantage to land animals which have limited access to water. Uric acid is expelled in a solid state. It is common method of excretion in birds, land, reptiles, lizards, snakes, etc. Insects, cockroaches, land snakes, and some crustaceans, woodlouse. Some other excretory products. Osmo Osmoconformers, the animals which change the osmolarity of the body according to the osmolarity of the surrounding are called osmoconformers. Example, all marine invertebrates and some freshwater vertebrates amongst vertebrates Then the hagfish is osmoconformer. Osmoregulators, the animals which remain in the osmolarity of the body irrespective of the surroundings. That is, they have the capacity of excreting a hypo or hypertonic urine. Example, all vertebrates except hagfish. Organs of excretion in animals. Protozoans, poriferans, mammalian. Platyhelminthes, protonephridia, closed tubular structures with flame cells or solenocytes. Ascalminthus, renate cells or head cells. Annelids, metanephridia, nephridia, ovotubular, integumentary nephridia, septonephridia, pharyngeal nephridia. Leech is botryoidal tissue. Arthropods. Crustaceans forms a green gland, a pair of them opening at the base, second and deep. Types of kidneys. Chrononephros or chrononephric kidneys, they remove waste material from body cavity by filtration of coelomic fluid. Example, all vertebrate embryos. Mesonephros or opsionephros. The kidneys are the nephrostomes to filtrate coelomic fluid and Bowman's capsule to filter blood. Examples, fishes, amphibians and reptiles. Mesonephros or opsionephros. The kidneys are the nephrostomers to filter a coelomic fluid and Bowman's capsule to filter blood. Fishes, amphibians, and reptiles. Methanophores, it is the waste removed from the blood alone. Example, some reptiles, birds, and mammals. Echinomorbs must maintain the primitivity with all the three types of kidney. Example, larva of hatfish. Kidneys. In humans, the kidneys are metanephric. Takes time. Let me explain what I did. The kidneys when I was fully running in my brain what happened. First breathing and exchange of gases, after that directly we can go with circulation because heart and lungs are more interlinked than heart and lungs and kidneys. So we go with lungs, then with heart, then with kidneys. But in this book, this is the method. Let me first explain once. Breathing and exchange of gases is all related to lungs, how we breathe, the process from the nostrils till the whole lungs, and all the types, the volumes, measures, and oxygen, the transpiration of oxygen, the transpiration of carbon dioxide, the curves of both the cases, and then the disease related to the respiratory tract. Those all then, even the brain controls. I mean, the CNS has the control over the respiratory system. That also CNS as well as the ANS. ANS part is there in this NCR. One column on these there. And these sigmoid graphs. Those all comes for breathing and exchange of gases for this sample. So for what I studied in kidneys, breathing and Excretory products, excretion, this part. How it's excreted. First thing we learn what all things are excreted and how it's excreted. Main thing, types of waste and what wastes are excreted, like the ammonic waste, ammonium, ammonotelic, ureotelic and uricotelic. And which all organisms go for which are types of excretion of wastes. Then we could, mainly now we're going to study about kidneys. We studied about the types of waste. Here it's more detailed, like how platyhelminthes does its excretion through the flame cells. So that is given here. Yeah, that is protorefridia. It's just given here. And some are just given in one line, like protozoans do through body surface. But here annelids we have in detail. Again, metanephridia, nephridia, and in that there is differences like integumentary sanctal nephridia, pharyngeal nephridia. Pharyngeal nephridia, that's new. I won't go in that next. So, what are the main important things? Always when we refer any book also, we should take any main important things. Too many unwanted things, if you take, it won't be useful. If you take now only all unwanted. Main things which they explain in depth is important because you'll have more understanding. Inside there's only one or two line explanation sometimes. It confuses. I like it. So that's why you should, if you prefer, if you like, you can refer. I also like to refer for that reason. Now, let me start again with types of kidneys. First we went to types of excretion, and in that we went through ammonotelism, ureotelism, then uricotalism. These were the three types of excretion we went through, and mainly the mammals do the ureotelism, not uricotalism. But all are ammonia based. But ammoniotelic is highly toxic and it requires more of water. Whereas ureotelic is less toxic than ammonotelic, and uricotelic is very least toxic. It requires less water in that case. That's why it's quite fluid, like semi-fluid kind of things. The excretory product of those, like land snails, birds, they all do the uricotelic, like frogs. Yeah, frogs. So those have, the urine is quite solidish. Not solid, like mucus kind of substance. Like it's given here, adenine of 1. This is in depth again. Those adenine, guanine acids and the substances, not acids, substances. I am going through that now. So, yeah. And these are some other excretory products also. So, okay. Osmoconformer is something which we went through, I believe. Yep. Okay. And osmoregulators. Osmoregulator is very important because osmoregulation. But osmoconformers is new thing. Right? The animals which exchange the osmolarity of their body according to the osmolarity of the surroundings are called osmoconformers. So like their body will be intact with the environment. Then only this works. Yeah, like hagfish. All marine invertebrates are some freshwater vertebrates. Amongst vertebrates only, hagfish is osmoconformer. So invertebrates there are many. And they're cold-blooded animals also. Whereas in vertebrates, it's hagfish. Nice. Osmoregulators. Then we even have osmoregulators. Osmoregulators is important. The animals which maintain the osmolarity of their body irrespective of their surroundings. That is, they have the capacity of excreting hypo or hypertonic urine. This is an important line, like hypotonic, hypertonic. What's the difference between hypotonic? It will come further with the urine excretion, like the process of urine, and like how the urine goes through the blood comes through the renal arterioles, then it enters the glomerulus, and it becomes a glomerular filtrate, and from that it goes through the penetrates, then through the penetrates it goes through the slit pores, through the slit pores it goes through the Bowman's capsule, and in the Bowman's capsule it goes through the PCT, after that PCT, then it DCT, DCT, in DCT that's descending limb of DCT, loop of Henle, descending limb of loop of Henle, after that it goes to ascending limb of loop of Henle, ascending limb of loop of Henle, after that it goes through the DCT, then after DCT collecting ducts, and like there are 8 nephrons or like 8 DCTs which one collecting duct possesses. So that's the case with the whole filtration process. In that there is one, what is this hypertonic medium. It's the hypertonic medium is always maintained for the osmoregularity of the body in the medullary interstitial fluid. That is the key point. That is an NCERT guidelines. In further we can study that. Over here they are given in crisp what osmoregulation is. Again, all vertebrates except hagfish. So now, as hagfish goes through the osmoconformers, it cannot do osmoregulation. Both of them cannot happen at the same time. They are completely opposite things. Then organs of excretion in animals quickly we'll go through. There are like one line here. Protozoans, poriferans, Medalians, body surfaces, platyhelminthes, protonephridia or plain cells, Ascalminthus, rennet cells or head cells, annelids, it's metanephridia, then arthropods, insects, malphigian tubules, then crustaceans, prawns, like one Greenland. That is, Greenland is even there for mollusks. Yeah, renal glands or organs. Then, yeah, Keber's gland also is known as, I hope I'm correct with the pronunciation, but Keber's gland. Echinoderms, amoebocytes, urochordates, neural glands, vertebrates, kidney. And now we'll study mainly about types of kidneys. There are different types of kidneys like the pronephros or protonephric kidneys. They remove waste from the body cavity by filtration of coelomic fluid. Example, all vertebrate embryos. So we have protonephros kidney or protonephric kidney. Mesonephros or opsinephros kidney. The kidneys which are nephrostomes to filter coelomic fluid and Bowman's capsule to filter blood. Example, fishes, amphibians and reptiles. Very specific organs are present throughout the organ system. Metanephros, the waste is removed from the blood alone. Example, some reptiles like birds and mammals. Okay, and Archinonephros, most primitive, which with all three types of kidney types. Example, larva of hagfish. Yeah, hagfish. Now we'll go through the excretory system of human beings. The main organs which we require are renal arteries, then kidney, aorta, renal veins, urinary bladder, uterus, vena cava, urethra. All these are important parts which we'll go through in depth. Kidneys. In humans, the kidneys are metanephric. That is metamorphism. One pair being shaped slightly flattened structures. One pair meaning two kidneys present on either sides of vertebral column at the level of 12th thoracic and first and second lumbar. 12th thoracic and first and second lumbar region. Lumbars are like the parts of bones. We have cervical bones, then thoracic bones, then lumbar bones, like the abdomen region bones, lumbar. Then we have the lumbar. It comes in locomotion. When it's in locomotion, we get that bones again. Cervical, thoracic, lumbar. I forgot those two bones extra exist, the sets of the lumbar region. But this is near the lumbar region. Yeah. And then the two kidneys are asymmetrically placed. The right kidney is slightly lower as being pushed by liver. Concavity of kidney has a longitudinal opening called hilum or hilus venalis. Through the hilum, renal artery and nerves enter and renal vein and ureter leave. It's the same path of entry and exit. Each kidney is surrounded by a tough fibrous capsule and then by fat. Outside the renal fat layer, there is fibrous membranes called renal phase. Extra points. Lateral surface of kidney shows that hilum leads to an extensively flat funnel-shaped space called pelvis. The pelvis is completely surrounded by renal tissue. The renal tissue has an outer part called cortex and the inner part called medulla. Outer part is cortex, inner part is medulla. Important point. Conical pyramid-shaped masses of renal medulla project into renal pelvis and are called medullary or renal pyramids. Renal pyramids are of 8 to 12 in number in humans. Nephrons are the functional units of kidney. Nephrons are arranged in a radiating manner in renal pyramids. Each kidney has about 1 million nephrons or renal tubules held together by connective tissue. About 8 nephrons open into one collecting. It's nephrons. 8 nephrons open into one collecting duct and are like millions of nephrons in one kidney. 1 million nephrons, one kidney. Urine is passed from collecting ducts to renal papillae, then to minor calyx and major calyx, and finally produced into renal pelvis. It's an opening. All those things. From renal pelvis, urine is connected by ureters. Okay, from renal pelvis, ureters to ureters, it gets stored in the urinary bladder. In urinary bladder, even it goes through the urethra, and urethral meatus is like meatus kind of opening again. Urethral meatus is through which the urine passes out. That point is like urethral meatus. Yeah, we have it here in ureter. One pair, long 25 to 30 centimeter muscular tubes, arise from renal pelvis and open in bladder through oblique openings on its dorsal wall. Oblique openings prevents backward flow of urine. So the oblique openings prevents backward flow of urine. Meaning once the flow is gone, it closes. Like in heart, we have studied about valves, just like that this works. Ureters are lined by transitional epithelium. Their function is to conduct urine. Urinary bladder. Large, thin-walled, pear-shaped structures lies in the pelvic region. The wall is made up of smooth muscles called detrusor muscles. So the wall of urinary bladder is made up of smooth muscles that is known as detrusor muscle. So what is the wall? That is detrusor muscle. This is important, the smooth muscle. The name of the smooth muscle is detrusor muscle. Detrusor. Lined by transitional epithelium ureothelium which makes it distensible. It stores about 0.5 to 1 liters of urine. The upper broad part is called the body of the bladder. Lower narrow part is called the neck of the bladder. The lower part of the bladder has 3 openings, 2 openings of ureters and 1 of internal orifice of urethra. The small triangular region with 3 openings is called renal trigone. Urethra. It is a muscular tubular structure. In females, it is about 4 cm long and opens out directly by an external urethral orifice above vulva. In males, it joins the ejaculatory duct and forms urinogenital duct, which is about 10 centimeters long and passes through penis and opens out by urinogenital aperture. There are 2 sphincters, internal urethral sphincter, it is an internal urethral orifice and is made up of smooth muscles. External urethral sphincter, it is an external urethral orifice and is made up of voluntary muscles. Types of nephrons. There are 2 types of nephrons based on their location. Cortical nephrons. They make up about 85% of all the nephrons. In cortical nephrons, most of the parts, malphigian, corpuscle, PCT, most of Henle, loop of Henle, and DCT, lie in cortex of the kidney. Only a small part of loop of Henle lies in medulla. They have petubular capillaries but do not have vasa recta. Vasa recta. This we'll study again at the blood getting refiltered. I mean that way, if there is no vasa recta present, it doesn't get refiltered. Simple ammonia doesn't get refiltered. It always gets thrown. It always is thrown out. It should be thrown out. Toxic substance. Why would anybody keep off the toxic substance? It leads to dangerous situations. Types of nephrons. There are 2 types of nephrons based on their location. Okay. Cortical nephrons. Cortical nephrons. They make up 85% of nephrons. That's what I read. They have petubular capillaries but do not have vasa. Then we have juxtamedullary nephrons. They make up 15% of nephrons. The juxtamedullary nephrons have their Bowman's capsule very close to the junction of the cortex and the medulla. Now the cortex and medulla. Cortex is after the lining of kidney. We get like one more lining. That layer present is the cortex. Then the medulla is the inner region. The first one, that is cortical nephrons, only the little portion of loop of Henle goes in through the medulla, and that is the reason why even vasa recta is even absent over there. They have peritubular capillaries, due to which vasa recta is absent. But in juxtamedullary nephron, loop of Henle also, then collecting duct also, both comes through the medulla. Yeah, that's what we study. The juxtamedullary nephrons have the Bowman's capsule very close to the junction of cortex and the medulla. They have long loops of Henle extending deep into the medulla. They have petribular capillaries and vasa recta. They have both vasa recta as well as petribular capillaries. Juxta medullary nephrons. Okay. Microscopic structure of nephrons, so like microscopic. Here all the descending, ascending limbs and all. The nephron is a structural and functional unit of kidney. Each nephron functions as an independent unit and produces minuscule quantity of urine. Each nephron is about 3 centimeters long and 20 to 60 micrometer in diameter. The nephron can be differentiated into following regions: Malpighian body or Malpighian corpuscle, Bowman's capsule, and glomerulus. Proximal convoluted tubule is PCT, then we have loop of Henle, then distal convoluted tubule is DCT. Malpighian corpuscle. It is also known as renal corpuscle or Pygmalion corpuscle. It was reported by Marcello Malpighi. This one becomes under two structures. One is like the Malpighian structure, another one is the tubular structure. We can do that flowchart. And yeah, by this Marcello Malpighi, we named it Malpighi. Tubule corpuscle. The thing is corpuscle because they are overlapping. That's the reason. This consists of two parts. So the Malpighian corpuscle consists of two parts, and you all know those two parts, that is Bowman's capsule and glomerulus. Bowman's capsule. This is a cup-shaped structure which is double-walled. It is lined by outer squamous epithelium and inner is made up of flat cells called podocytes, have finger-like projections. And now we can ask why they have finger-like projections. The thing is, the reabsorption starts from here. When the filtrate starts getting prepared from here, as soon as the blood enters from the renal artery into the kidneys and then enters the Bowman's capsule, over there only these ciliated projections start reabsorbing the minerals, especially glucose and all should be like 100% reabsorbed. They should not even be wasted. That is the point of reabsorption. And all the toxic substances should not even a percent should be reabsorbed. That is the point of again reabsorption. First one time they'll do the absorption. After absorption, anything which it gets absorbed again in the kidney is reabsorption. So, thus the blood which consists of waste materials, but again which kidney thinks as like, okay, this is not waste, let's accept it. Those are all like reabsorbed materials. They get utilized, but I'm not sure of what they get utilized. Yeah, I should say. If you know, put it down in the comments there. It will be useful. Fine. So the outer wall is like the squamous epithelium and inner is podocytes. Am I right? Yeah, I'm right. Glomerulus, the second part, it is a tuft of capillaries. Approx are like up to 50 parallel capillaries in glomerulus. An afferent arteriole enters here. Arteriole. It all starts from left ventricle, then the aorta. From the aorta, it goes to the abdominal. A branch of aorta has the abdominal artery, then arteriole. Yeah. From the abdominal arteriole, another branch comes, and that is this. Arteriole, afferent arteriole. Then efferent. Efferent is the exit. Afferent is the entry. Efferent is the exit. Both of the entry also through the renal hilum, the notch kidney, and the exit also through there. But over there, only vein exists. The path to another one, the waste material, this ureter. 50 capillaries. That's good. An afferent arteriole enters the cavity of Bowman's capsule and divides into about 50 parallel capillaries called glomerulus and leaves as afferent arteriole. What I told just now. The diameter of afferent arteriole is wider than the efferent arteriole. This is quite known. Why it can be a question. So I am saying, why is afferent arteriole more wider than the efferent? Because afferent arteriole, when it enters, it has more impurities. Like I told, there are already projections present in this. The glomerulus creates a filtrate and the reabsorption starts from here. So due to that, efferent arteriole doesn't need to be that wider as compared to the afferent arteriole, because the amount will be less. Obviously, the filtrate should start decreasing. More of more should also not get excluded. What is that? That's also more deadly. Those all are again diseases which we'll study later. After the next part, only half of this chapter is left. The diameter of afferent, that we did. A glomerular wall has many pores, so it's permeable to is 100 to 100 times greater than regular capillaries. Fenestries. Those pores are fenestries. There's name for those pores. The space between two walls of Bowman's capsule is continuous with the lumen of the next part of the nephron. The Bowman's capsule and glomerulus together constitute the renal corpuscle or Malpighian body. Now we go to the tubule part, that is the renal tubule. This is the coolest part. Renal tubule. This is the remaining part of the nephron, continuous with the Bowman's capsule. It is lined with ciliated epithelium and differentiated into following regions. Proximal convoluted tubule, PCT. This is the region behind the Bowman's capsule and consists of a coiled tube about 12 to 24 mm in length. Right. It descends from the Henle's loop. Anything which comes towards like this. That's why it's descending. It goes after ascending. The proximal convoluted tubule is present in the cortex region. This is new point. Cortex region. It is lined by cuboidal brush-bordered epithelium to increase the surface area for absorption. All of these are lined by something. The only thing is descending. This is only lined by epithelium. The cells of the epithelium have numerous mitochondria for active reabsorption. Possessing numerous mitochondria helps in active reabsorption and fast reabsorption. So active, fast, same thing. Henle's loop. This is continuous with the proximal convoluted tubule. It is the U-shaped hairpin-like part having a thin descending limb and a thick ascending limb. Okay, now here you might think, why is the ascending limb thick? It should have less waste. Simple. It's going against the gravity. So you need a bit extra force. Like in heart, again we study the thing which goes against the gravity, like the pulmonary artery. Artery doesn't have, artery. It has more thickness. Like the pressure, it should bear the pressure. That's it. Everything is linked and related in human body. Next. Ascending lymph is impermeable to water but permeable to NaCl, and descending lymph is permeable to water but not NaCl. These permeables are nothing but what they are containing, like what they reabsorb, what reabsorption takes place. There's a diagram in NCERT also we have, like the arrow mark one which is like showing the inward, that is reabsorption, another one showing outward, that is secretion. So what all parts get reabsorbed in where, like what all substance get reabsorbed in which parts, and what all are secreted from which parts. Those all are mentioned. That is the same thing in NaCl and H2O. H2O in TL, in descending lymph of loop of Henle, ascending lymph of loop of Henle has NaCl. This loop descends from the cortex region into the medulla region, like we studied cortex and medulla. Loop is longer in birds and mammals, animals who can excrete hypertonic urine. Like I told you, we'll study hypertonic and hypotonic more in detail further. Now we'll study hypertonic and like tonic solution. Here this we have like what's tonic basically. Tonic is a solution. What makes it hyper? Hyper is more concentrated. Hypo is less concentrated. So we take a solute. A solute normally exists like water. If you add more solute, like if you add solute, it becomes a solution, first case. And if you keep on adding more solute, the solvent starts decreasing, meaning the concentration starts decreasing. It goes like -1, -2. Original concentration of solvent is 0. Basically, that's maximum. Later, it starts decreasing. That's one of the logic, and that's what makes the solution hypertonic, more concentrated. Like whatever solute we are adding to any solution, it depends. So that makes the solution tonic, hypertonic or hypotonic. It's a part of chemistry. Where was I? Loop is longer in person. Loop may be shorter or absent in vertebrates like the reptiles. That's a case. Distal convoluted tubule. From here it goes to the distal convoluted tubule. This is another coiled and twisted tubule that continues from the ascending limb of loop of Henle, found in the renal cortex. Now again back to cortex position. From medulla we went back to cortex. Lined by cuboidal epithelium. Yeah. This descending limb is lined by squamous, but I don't know why they're giving cuboidal here. The only limb which is lined by squamous epithelium is descending limb of loop of Henle. Did they mention that also cuboidal limb? They mention. Here. Got confused. That's one more point. The only part where it's squamous epithelium lining, that's the descending part of loop of Henle. It's like highlighted, only part. Ascending limb is again cuboidal. Everything else is cuboidal epithelium, the brush board, cuboidal, but only descending limb has squamous. Found in renal cortex lined by cuboidal epithelium, opens in collecting duct. Yeah. This opens back fully out of collecting duct. Now, collecting ducts. Collecting ducts receive the nephric filtrate from about 8 nephrons. Collecting duct converges towards the hilum into the duct of Bellini. So after the hilum, it goes to the duct of Bellini, and yeah, those are other further ducts. Before it reaches the urinary bladder, there are certain pathways the urine follows. Basically, once it's fully filtered out and all the substances are filtered or like reabsorbed, then it becomes a urine. Until then, it's like a filtrate only. Anything which is not completely reabsorbed, like partially done, it's filtrate. Once it goes through the collecting duct, and once especially it's passing out through the ureter, then it's urine. Then it's stored in the urinary bladder as urine. Ducts of Bellini. Several collecting ducts join to form the larger ducts of Bellini in the medulla region. So we are still in the kidney. Running through the pyramids, they open in to calyx minor, then into calyx major, and finally open into renal pelvis, draining all the urine collected from various nephrons. The renal pelvis is an expanded region which opens to the ureter. So when all the urine is drained to the renal pelvis, this opens to the ureter. And yeah, as in renal pelvis itself, it's urine. So from there, it's fully urine. This urine is hypertonic solution. That is, it's concentrated. It is concentrated. About 6 to 6 in pH. It comes around 6. Not more concentrated, but acidic. Only 6 is acidic. Okay. Then we have renal blood supply. Each kidney receives blood through a renal artery from the abdominal aorta. We have the whole process how it comes. Inside kidney, the renal artery divides into branches called interlobar arteries. Each interlobar artery divides in many afferent arterioles. Then afferent arteriole enters in the cavity of Bowman's capsule and forms a tuft of capillaries called glomerulus, a set of capillaries with highly hydrostatic pressure. Hydrostatic means anything which involves water. Static means it's without any change is static. Hydrostatic pressure basically. And the blood from glomerulus is drained by afferent arteriole. Afferent arteriole breaks up into petricular network of capillaries, second set of capillaries with low hydrostatic pressure, meaning its reabsorption is starting to take place. Petricular capillaries join and finally form renal vein. Renal vein opens into post-caval. Renal venous blood has two capillary beds. Glomerular high pressure 60 mm of Hg, petricular low pressure 13 mm of Hg. Petricular capillaries also form loop like vasa recta and juxtamedullary nephrons, which help in counter current. So now we didn't study what exactly vasa recta is. So vasa recta is like present as a counter or like proximal kind of thing to the PCP. This is where the medullary interstitial fluid also comes into the play. From there, the fluid enters the DCT, then enters the DCT, collecting, then comes out. Next part, here. In the formation of urine, we studied. I'll tell you promptly. The formation of urine takes place by three processes. So, ultrafiltration, glomerular filtration. We have only up to formation of urine, then we will. Ultrafiltration, glomerular filtration. Ultrafiltration occurs through a filtration membrane at an effective filtration pressure, that is glomerular filtration pressure. Filtration membrane is made up of three layers: endothelium of capillaries, basement membrane of the wall of glomerular capillaries, epithelial layer of Bowman's capsule made up of podocysts. Efferent arterioles being narrower than the afferent arterioles, the blood pressure is twice in glomerulus as compared to other capillaries. Blood enters the glomerulus at glomerular hydrostatic pressure of 60 mm of Hg. Pressure providing resistance are osmotic pressure. Colloidal osmotic pressure of plasma contains albumin. Albumin we studied in the blood fluids chapter. Like albumin helps in the osmoregulation. That component. Albumin comes under plasma. The glomerular capillaries. PO is of 30 mm of Hg, that is this osmotic pressure. No? Hydrostatic pressure PC of fluid present in renal tubule is about 10 mm of Hg. Hydrostatic pressure is interstitial fluid of renal tubule is around 10 mm of Hg. So GFP, glomerular filtration pressure. So to know the exact glomerular filtration pressure, we are doing some calculation here, that is about 10 mm of Hg. We add, subtract all those things. The original round off is 10 mm of Hg. Whatever values I told, only for 60 is the main value. Rest all you have to sum together. After summing them, subtract it. 60 if you want, and then 60 minus 50 will take this. Like 60 minus in the bracket 30, 10 plus 10, 50. 60 minus 50, 10 mm of Hg is the glomerular filtrate pressure. Only till here, then we are done with this. And quickly go through the body fluids and circulation part. It's like the ECG and all the main parts. The glomerular filtration pressure, GFP, is about 10 mm of Hg and is responsible for filtering a large amount of water, glucose, amino acids, vitamins, sodium, and a number of harmful substances like urea, uric acid, serotonin, ammonium salts, pigments like potassium. Serotonin. This is quite something which you have not heard so far, right? You have heard me telling ammonia, urea, uric acid, everything, but not serotonin. This is the highly toxic waste substance which will not at all get reabsorbed. Like even 0.001%, you can think it won't at all get reabsorbed. So you can actually see it in the end, like in the collecting ducts only you'll get to know these are the wastes getting excreted. Till then you won't even know the waste actually, especially the serotonin. Okay, the proteins, fats and carbohydrates are not filtered out. Like I told you, they're not filtered out because it's needed for the body. How much ever the body by chance it will give off like academians. But later in the kidney it really filters out what all is required and what all is not. These are some essential essential substances. Even if it's not required for time being, later it stores. Because one day if someone starts like I'm fasting, it needs no fat. This filtrate is called nephric or glomerular or capsular filtrate or primary urine. First filtrate is the primary urine. The glomerular filtrate is same as blood minus cells and proteins. So first we remove the cells and proteins. Then it resembles the protein-free plasma in cosmopolitan and osmotic pressure. It is almost isotonic to blood. Okay, about 650 ml of blood passes through the glomerular capillaries in all nephrons of both kidneys per minute. This is called renal plasma flow. But about 125 ml, that is glomerular filtration rate of filtrate is filtered out. So about 150 to 180 liters, average 172 liters of nephric filtrate is formed per day, but only 1.5 to 1.8 liters of urine is excreted out per day, and this is called urine output. So you can see the amount of urine actually being excreted and the amount of waste or like the filtrate is actually being formed, meaning majority is being reabsorbed by the body. Only very harmful substances, toxic substances are reduced, like the given outcomes. Okay, then that is the glomerular reabsorption. That's the first type. Second, we have selective reabsorption. Selective reabsorption. The main function of reabsorption is to maintain homeostasis so that volume, electrolytic balance, composition, pH and osmotic pressure of blood are kept constant. Substances which are reabsorbed are divided into three categories on the basis of amount that they are highly absorbed in. High threshold substances. They get absorbed completely or mostly, like that I told. Example, glucose, amino acids, water, vitamin C, sodium, etc. Renal threshold value. Upper limit of kidney up to which a high threshold substance can be absorbed. Example, 180 mm of Hg per 100 ml of nephric filtrate for glucose. Glucose is majority it gets reabsorbed. It is hard. It doesn't get excreted. Why would it get excreted? Low threshold substances. They are slightly absorbed. Example, urea, uric acid. Then we have no threshold substances. They are not at all absorbed. Example, serotonin and hyaluronic acid. Correct what I told again? Two processes which help in reabsorption. Diffusion, it is a physical process. Substance move along the concentration gradient. Example, water vapor. We studied concentration gradient in circulation. That time we were studying concentration gradient, right? Even before that, like for us they explained concentration gradient when they were doing breathing and exchange of gases. So we will now, like future we won't ask what is concentration gradient. It's like the gradient, what is actually? Is the amount of concentrated substances, like highly concentrated, okay, like the neutral concentrated, then the low concentrated substance, and at what rate anything can be absorbed at a gradient, only at the given pressure, partial pressure, given substances at that point, like I think. It links into active absorption. Absorption takes place against the concentration gradient. It requires energy. So if this is going to happen, it's like too much energy will be required. If you go anything against, like just a blood flow going against a gravity requires more of energy, pressure and all. Just like that only, this requires more pressure, more energy. Reabsorption in PCT. The PCT actively absorbs almost whole of glucose, 75% of amino acids and vitamin C, not for acid, 70% sodium and 75% of potassium, large amount of calcium from the glomerular filter. Calcium is mainly absorbed, reabsorbed. Both, many things required. We even studied calcium for the clotting factor. It's one of the clotting factors. Remember? You should remember the clotting factors. They ask questions based on clotting factors, and that's the important part. About 65 to 80% of nephric filtrates gets reabsorbed in PCT. So it is the main site of absorption. So the main site of absorption is PCT. So though the glomerular filtrate is like main, but major of the elements gets reabsorbed in PCT. Now you might think like, what's the use of loop of Henle in DCT? See ahead. Reabsorption in loop of Henle. Ascending limb of loop of Henle, diluting segment of nephron. It is impervious to water. It actively reabsorbs about 25% of potassium and some chlorine ions passively. Some sodium gets passively absorbed. Descending limb of loop of Henle absorbs water. Reabsorption in DCT. DCT and the collecting tubules actively reabsorb some sodium from nephric filtrate in exchange with potassium of the interstitial fluid. Okay, now this is quite an interesting thing, that is the DCT and the collecting tubules together actively reabsorb some sodium and they release some potassium to the interstitial fluid, like the medullary interstitial fluid. Why the name medullary? Because it's present in the medullary region. Reabsorption in collecting duct, absorption of water, some urea and sodium takes place. So if you keep on reabsorbing water, what will even be left in a solution? Only toxic substances. Only those get excreted. Now the third part, that is tubular secretion, also known as augmentation. It is a process by which the glandular cells of nephron, especially of DCT, extract the waste like uric acid, serotonin, uric acid, potassium plus, hydrogen plus, hydronium whatever, ammonium from the blood in the capillaries by active transport and secrete them in nephric filtrate. You know what happens once it goes to the nephric filtrate. Most potassium eliminated in urine is secreted by DCT and collecting tubules in exchange with reabsorbed sodium. It is the only mode of excretion in marine fishes and desert amphibians whose nephrons are without glomeruli and Bowman's capsule. Meaning water before we studied does not exist. Only this part exists in them. Potassium shows bidirectional transport. Yeah. Potassium. Now, like as a result of about 3 processes, the wastes are changed into urine. So we can know the characteristics of urine. Simple color, yellow due to the presence of a pigment called urochrome formed by the breaking down of hemoglobin. Vitamin B complex, certain drug, bed, etc. change the color of the urine. Specific gravity. Specific gravity is nothing but density. About 1.003 to about 1.04, slightly heavier than water. Tonicity, hypertonic. Yeah, pH 6, right, we told it right. pH is 6, acidic. Range is about 4.5 to 8. 8 means basic. Basic is not good. Urine doesn't be basic. Urine is always concentrated. Okay. Odor, like why does it smell? Smell is due to urinol, a bad smelling substance. Ammonia like smell, particularly if stale. This is because bacteria convert urea to ammonia. Yeah, that's the basic composition. We have certain specific values to know also. So not important, but what all are there in the urine? If we go through the organic constituents of nitrogen, urea, serotonin, ammonia, uric acid, hypuric acid, oxalic acid, amino acid, alination cases, vitamins, hormones, enzymes, traces. Inorganic constituents, these all are very less. Very less amount of organic constituents are excreted compared to inorganic constituents. Chloride, NaCl, then phosphate, sulfate, potassium, sodium, calcium, magnesium, iodine, arsenic, lead. Nitrogenous base found in urine and urea, ammonia, uric acid, serotonin, and hippuric acid. Salts like sodium chloride, traces of mineral ions like sulfates, chlorides, phosphates, sodium, calcium, magnesium, iodine, vitamin C, oxalic acid, alcohol, hormones, and enzymes are also present. Glucose and proteins are normally absent. They are detected in the case of diseases like diabetes, mellitus, or in kidney failure. So this is the reason glucose and protein should never be excreted. This is sometimes always useful for a human body. So yeah, just say by chance, if by any test they could get to know that glucose and protein is excreted, that means the person might be suffering from diabetes or kidney. That's that. Daily urine output is about 1.5 to 1.8 liters. So the amount of urine excreted by a person per day is about 1.5 to 1.8 liters. Urine output increases with increased intake of water or fluids. Substances like tea, coffee, alcohol, etc. act as dietary, increase volume of urine by decreasing the secretion of ADH. Exercise, rise in temperature, and excessive sweating decrease the volume of urine. Now, why this might be? Think and answer in the comments. I won't answer. This is old question. We used to get in 10th and conduction of urine and micronutrition. We don't have that so far. So I'll be going on to the next chapter. Body fluids and circulation. Where's this written? Maybe I have to press this off. Cardiac cycle. Body fluids, I'll crisp this chapter to the main key points only. So now we know first thing, the main component of this chapter is the blood. So the blood is red in color, vascular, liquid, connective tissue it is opaque, meaning opaque, we know it, light doesn't pass through it. It's 5 times more viscous than distilled water. Viscous means slimy. Blood is slightly alkaline with pH 7.4, meaning slightly alkaline because in point it's more. Normally 7 is the neutral value. So in point it's more, that's why it's alkaline. That doesn't mean it's so alkaline or so acidic. It's very deadly if it's like that. Blood has 2 parts, plasma and formed elements. So now plasma. It is faint yellow, non-living fluid, makes about 55% of the blood, that is 45. Composition of plasma, water is 90% to 92%, more is water. Inorganic salts 1% to 2%, like same thing, organic compounds, food molecules, waste, sea waste, urea, uric acid, serotonin, enzymes, hormone, antibodies, gases. Plasma protein 6% to 8%, albumin, osmoregulation, albumin. Globulins for immunity. Then fibrinogen and prothrombin, that is clotting factors. Then glucose is the blood sugar. Normal blood sugar level is up to 120 to 180 mg per 100 ml of blood. Per 100 ml of blood. Urea is the chief nitrogenous waste. So yeah, urea is chief nitrogenous waste. Serum, plasma without clotting factor is known as serum. So this might like always is an MCQ. What is serum? Or plasma without clotting factor is known as serum. Functions of plasma: transport. Plasma helps in transport of nutrients, respiratory gases, metabolic waste hormones. Homeothermy: plasma helps in equal distribution of heat. Maintaining pH: plasma acts as acid-base buffer. Blood clotting: prothrombin and fibrinogen help in blood clotting. Immunity: gamma globulins act as immune globulins, antibodies. Plasma acts as middleman in support of substances, transport of nutrients. Transferring globulin helps in transport of iron. Then ceruloplasmin globulin helps in transport of copper. Plasma protein albumin holds water and maintains osmotic pressure. Plasma carries blood corpuscles. Then we have blood corpuscles. Blood corpuscles is the formed elements. So they make 45% of the blood, like I told. They are of 3 types: RBC, WBC and platelets. RBC, red blood cells; WBC, white blood cells; platelets. So which is more in number? RBC. We all know. RBC also known as erythrocytes. They never ask what's RBC, they always ask what's erythrocytes. In all vertebrates, RBCs are oval, biconvex and nucleated except mammals. So we don't have nucleated erythrocytes. In mammals, except camels and llama. So there's an exemption. In camels and llama, so it's nucleated only. The mature RBC is circular, biconcave and non-nucleated. Mature RBC is without nucleus and all other organs. Biconcave shape increases surface area to volume ratio, and absence of nucleus increases hemoglobin content. So as a nucleus is absent, we have more hemoglobin. That's important. RBC is about 7 to 8 micrometer in diameter. Diameter is 7 to 8. Number of RBC differs in different animals as well as with physiological state of an individual. Total number of RBC count we have, so like about 4.5 to 5.5 million per millimeter cube. Instrument used to determine RBC count is hemocytometer. Yeah. RBC count increases due to physiological state, higher in athletes and swimmers. This is always a question. What is higher? It's always in athletes and swimmers, everything is high. At an high altitude. Why it's high? There are scientific reasons. Their body functioning itself is different. But we studied in the breathing and exchange of gases, the lung capacity is even high for divers. Some things are exemptions, only some things are high. Normally it's for athletes and swimmers it's high. This is like a short question. They always ask these in exams. RBC count is more than normal, then it's known as polycythemia. RBC count is less than normal, then anemia. Everyone is familiar with anemia. A human RBC has an elastic semi-permeable plasma membrane called Dornan's membrane and is capable of squeezing through fine capillaries. Dornan's membrane. Due to absence of nucleus, RBCs are short-lived. Average lifespan of RBC is 120 days. Old and worn out RBC are destroyed by what cells? Reticuloendothelial cells of liver. It's also known as comfort cells, and spleen, also known as graveyard of RBC. The process of breakdown of RBC is called hemolysis. Everything is related with heme. Okay, what is heme? It means iron. HB is broken down into iron-containing pigment, hemosiderins, and bile pigments, bilirubin and biliverdin, excreted out in feces. Each RBC takes about 50,000 circuits in the body before being hemolyzed, meaning this much work it does. RBCs are hemolyzed at the rate of 2.5 million per second. But are also formed at the same rate. That's the coolest part. Like at 2.5 million, they are dead also per second, and at the same rate they are formed at the same rate. Formation of RBC is known as erythropoiesis. Erythropoiesis takes place in erythropoietic organs like liver and spleen in embryonic stage and red bone marrow after birth in presence of an enzyme called erythropoietin secreted by kidney. Erythropoietin is secreted by kidney. The entire process of erythropoiesis is completed in 72 hours. Hemopoiesis is controlled by iron and proteins while maturation of RBC by folic acid and vitamin B12, also called erythrocytes manufacturing factors. Deficiency of B12 causes pernicious or megaloblastic anemia. So even deficiency of vitamin B12 also causes megaloblastic anemia. There are different types of anemia, but this is different. Megaloblastic anemia. I don't know what goes wrong with this anemia. RBC count low. Megaloblastic. Excess of RBCs are stored in spleen. Excess are also stored in spleen. They are even dead over there. Spleen acts as blood bank as well as graveyard. See what I told you. Spleen acts as blood bank as well as graveyard of RBC. RBC is a purple colored iron containing pigment, that is, it is a conjugated protein formed of 4 heme groups and a protein globin, HB4. The formula itself says. Each heme group contains an iron containing porphyrin ring formed of 4 pyrrole rings, and globin is formed of 4 polypeptide chains, 2 alpha chains, 2 beta chains. One RBC contains about 280 millions of high HP molecules. So one RBC contains about 280 molecules. Yes, 280 million molecules of hemoglobin. Amount of hemoglobin per 100 milliliters of blood is called HB count. That is hemoglobin count. It is measured by an instrument called hemometer. HB count in females is about 12 plus 2 grams per 100 ml, but HB count in males is more. It's about 14.5 plus 2 grams per 100 ml. 1 gram of hemoglobin carries 1.34 ml of oxygen. Functions. Hemoglobin has a great affinity towards oxygen and forms an oxyhemoglobin complex and helps in transport of oxygen. One hemoglobin can carry 4 molecules of oxygen. Hemoglobin also helps in transport of CO2 as carbon in hemoglobin. Hemoglobin acts as buffer and helps in maintaining constant pH. What all acts as buffer? Even hemoglobin acts as buffer, plasma also acts as buffer. WBC, leukocytes. They are rounded or amoeboid, nucleated, non-pigmented cells. These are wandering cells and are capable of coming out of capillaries by amoeboid movement called diabetes. Size of WBC ranges from 8 to 15 micrometers. Number of WBC is much less than that of RBC. The ratio of WBC to RBC is 1:600. Total number of WBCs per microliter is called total leukocyte count. TLC of a healthy person is approximately 5,000 to 10,000 millimeter per millimeter cube according to NCRT. The range is of 6,000 to 8,000. According to NCRT's range of 6,000 to 8,000. Average TLC is of 7,000 per millimeter. Whenever we take average, we take the real value, so this is the average. Rise in WBC count is called leukocytosis. Fall in WBC count is called as leukopenia. Anything fall is penia, rise is cysis. I mean, those are the suffixes you put there. Leukemia is pathological increase in WBC count and denotes a neoplastic disease, blood cancer. Function of WBC occurs in bone marrow, ears patch, lymph nodes, thymus, and spleen. These organs are called leukopoietic organs, and the process is called as leukopoiesis. WBCs are of two types: granulocytes and agranulocytes, like we all know. They have granular cytoplasm. The granules are of lysomes and Golgi bodies. Nucleus is lobed, and the number of lobes is of 2 to 5. And so they are also called polymorphonuclear leukocytes. They are produced in red bone marrow from precursor cells called myoblasts. They make up about 60 to 65% of the total WBCs. They are divided into three subtypes on the basis of nucleus and staining reaction of granules of cytoplasm. Okay. So first thing, neutrophils. They make 62% of the total WBC. They are most abundant, stained by both acidic and basic dyes. Size varies from 10 to 12 micrometer. Nucleus is 3 to 5 lobe. They are the chief phagocytes called soldiers. Lifespan about 10 to 12 hours. During infection, many neutrophils die and form pus. They help in the identification as nucleus of females and have bar bodies which represent the inactivated of X chromosome, and so are called what are the chromatids. Basophils. They make about 0.5 to 1% of the total WBC, least in number. Size is of 8 to 10 micrometers, stained by basic dye like methyl blue. Nucleus is 2 to 3 lobe or S-shaped. Lifespan is of 8 to 10 hours. These are the neutrophils. They secrete heparin, anticoagulant, histamine involved in inflammatory reactions, and serotonin, vasoconstrictor. Acidophils. They make up 2 to 3% of the total WBC. Size ranges from 10 to 15 micrometer. They take acidic dye like eosin, so-called eosinophils. Nucleus is bilobed. Lifespan is of 14 hours, more than both of them. The number increases in allergic reactions. They get triggered during allergy, asthma, and even hay fever. Hay fever. It's caused due to the pollen grains. They resist infection and are associated with allergic reactions. Infections they resist, but allergic they are associated. They help in healing of wounds by destroying the toxins produced by microbes. Yes, then we have agranulocytes. Cytoplasm is non-granular. Nucleus is not loud, makes about 35% of WBC. They are of two subtypes, monocytes and lymphocytes. We have monocytes, they are large amongst all leukocytes. Size ranges about 12 to 50 micrometer, maybe up to 20 micrometer. They make up 3 to 5% of TLC, that is total lymphocytes count. Their number is about 100 to 400 per millimeter cube. The nucleus is oval or kidney shaped or horseshoe shaped, and it's usually eccentric. They are formed in lymph nodes and spleen. They are phagocytic in action and make the second line of defense. They also act as scavenger cells or macrophages and remove dead cells from body. Lymphocytes. They make of 20 to 25% of TLC. Their number ranges from 1500 to 2700 per millimeter cube. Size ranges from 8 to 12 micrometers. Nucleus is large and round. Cytoplasm is thin and peripheral, formed in thymus, lymph nodes, spleen, tonsils, etc. They produce antibodies. Here they is shaped. Okay, even as shapes, like what is neutrophil like. They give a shape. Identify this is neutrophil, this is acidophil, this is basophil. So you have the shapes. So the multi-lobed one is neutrophils. The bilobed one is the granulocytes. Eosinophils or acidophils. The spiral like S-shaped nucleus is the basophil. Monocyte we have. Both is like the more space present when the nucleus is a bit bulged. That is monocyte. The nucleus is properly present and only a layer of cytoplasm is seen, then that is lymphocyte. Like here the diagrams. Then we have blood platelets and blood groups. Okay. Blood platelets, these are smallest size blood corpuscles, 2 to 3 micrometers, found in the blood of mammals only. They are colorless, oval and discoid and are formed by fragments of special cells called bone marrow called megakaryocyte. Non-nucleated, each plate has a mass of basophilic granules in the center which give an appearance of nucleus-like structure. The number ranges from 1.5 to 3.5 into 10 to the power of 5 per millimeter cube of blood. Decrease in number of platelets is called thrombocytopenia. So the decrease in the count of platelets is known as thrombocytopenia. Thrombocytopenia. Decrease in the blood platelets. Increase in number of platelets is known as thrombocytosis. Lifespan is of 7 to 10 days. They get phagocyted by leukocytes. They help in blood clotting on injury. Platelets release many plate factors and an enzyme called thromboplastin. Prothrombin is the activator. So for the thromboplastin, prothrombin is the activator, which helps in blood clotting. Platelets also secrete a vasoconstrictor called serotonin, derived from tryptophan. Thrombocytes. They are found in vertebrates other than mammals. They are also called spindle cells due to their spindle shape. Nucleated, nucleus is oval, help in blood clotting. Now we have the blood groups. ABO blood group system was discovered by Karl Landsteiner in 1900. Karl Landsteiner. Blood groups or blood types are based on the presence or absence of antigens on RBCs and presence or absence of antibodies in plasma. ABO blood groups are based on the presence or absence of two surface antigens and RBCs, namely antigen A and antigen B. ABO blood groups are controlled by 3 alleles of gene called multiple allelism. The allele IA and IB are dominant and IO is recessive. Dominant alleles are responsible for formation of surface antigen on RBC. If antigen is A, plasma will have antibody A, anti-B. Antibody which has no, it will antigen, that is anti, it will be right opposite to the what it doesn't have it. If it has A, it will be opposite to B. If it has B, it will be opposite to A. An individual can have any of these alleles, so the possible combinations are, we have certain combinations. I'll go with the antibody and the antigen combination rather than allele combination. For allele combination, you should go through what Mendeleev explained. You should again do the square box, then place them according to the blood groups like the alleles IA, IP, IO, then again IA, IP, IO, and match them. There you will get the allele pairs. Here you can directly get the blood group, the antigen, the antibody. This is Karl Landsteiner's. Allele basic is given by Mendeleev. Later more developed is by Karl Landsteiner. ABO system is Karl Landsteiner. That is for sure. Okay, antigen is A only. Antibodies can be given to a person with blood group A and AB. Can be taken from a person with blood group A and O. B. Antigen is B and antibody is A. Small. Can be given to person AB. Antibodies is none. Antigen is A. Can be given to a person with blood group AB only. Can be taken from a person with blood group AB, A, B, and O. O. None. There is no antigens present, but antibodies A and B can be given to a person with the blood group O and AB. Can be taken from O. From the above table, it can be concluded that AB blood type is universal receptive. That is, a person with blood group AB can receive all blood types. O blood type is universal donor, that is, this blood type can be given to person with any blood type. In O also, O negative is universal donor. Okay. During transfusion, blood group matching is essential to avoid antigen-antibody reaction. Example, if a person with blood group A, antigen E and antibody B is given the transfusion of blood type of B, antigen B and antibody A. Okay. The antibody B will react with antigen B and antibody A will react with antigen E. This results in destruction of RBC resulting in anemia and jaundice. Even it causes death, not only anemia and jaundice. If RBC is fully destructed before it's formed, it's dead. Such reaction between different blood groups is known as ABO incompatibility. ABO incompatibility results in milder reactions like mild anemia and jaundice. If it's in a human, like here they are telling blood transfusion. In adults, then mild. RH factor. Another antigen RH detected in rhesus monkey. RH stands for recessive and rhesus is a monkey. Is also found on the surface of RBC. 80% of human population has the antigen, so they call it RH positive, and 20% who do not have it are RH negative. Blood matching is essential to check RH compatibility. Antibody against RH antigen is not normally present. These antibodies are synthesized only on exposure to antigen. A special case is when the pregnant female has RH negative blood and the fetus in her womb is RH positive. RH antigen on fetal RBC does not come in contact of maternal blood, as the maternal blood and fetal blood are separated by placenta, but during maturation, that is during delivery, mixing of blood takes place and the mother's blood receives RH antigen from fetal blood. Mother's body parts now prepare for antibody against RH antigen. As in first delivery, mixing takes place for a very short period of time, only during maturation, so the reaction is not as fast. In subsequent pregnancies, RH antibody from mother's blood goes to the fetus, destroying the fetal RBCs. This causes severe anemia and jaundice and can be fatal, can be really fatal. This condition is called erythroblastolysis. Erythroblastolysis fetalis. Erythroblastolysis fetalis. This can be avoided by administering anti-RH antibody to mother immediately after the first delivery. Now this is the whole process of blood clotting. Blood clotting or blood coagulation. So then we have certain blood clotting factors. Main is the fibrinogen synthesized in the liver, prothrombin synthesized in the liver, thromboplastin. This is enzymes released from damaged platelets. Then here calcium ions activate thromboplastin. Those are important. That's what it is. See, there's one more called Christmas factor of plasma thrombin form. We don't have that. Process of blood clotting is completed in 3 steps. Formation of thromboplastin or prothrombin activator. So thrombin extensive pathway, injured tissue. So this is process of clotting. Injured tissue, then tissue thromboplastin, lipoprotein plus phospholipid. Then it goes to activated X thrombokinase S prothrombin activator is activated. Then through intrinsic pathway it goes to the injury of the blood vessel. Then activates all the other factors which we actually is given there in the table here. X means Hagman or surface factor. Then this thing means again like the Christmas factor. Then this X means status power factor. There are other factors which it activates. We are familiar with 4 factors as given in NCERT and we'll go according to that. So the conversion of prothrombin to thrombin. Prothrombin with the help of an enzyme called thrombokinase is converted to thrombin. Conversion of fibrinogen to fibrin is by fibrinogen by an enzyme of thrombin is converted into fibrin monomers, which is insoluble, and monomer is insoluble. Worn out cells get entangled in network of fibrin to form clot. Normal clotting times are 4 to 10 minutes. So normally any clotting takes place by 4 to 10 minutes. Lymph and lymphatic system. It's a white color vascular connective tissue. It's alkaline and is present between blood and tissue, also called tissue fluid. It's made up of two parts, plasma. Plasma is very similar to blood plasma except that it has less proteins, calcium and phosphorus. Lymph plasma is derived from blood by ultrafiltration. Ultrafiltration, the kidney one. Leukocytes or lymphocytes, they are floating amoeboid cells less in number. Lymph equals to blood minus of RBC, platelets and some proteins. Functions of lymph. Lymph acts as middleman between the blood and the tissue and helps in exchange of material. It keeps the tissue moist, very important one. It helps in transport of fat from intestine to liver and pours it in venous blood. This fat which is poured in venous blood goes through the renal artery and into the kidney. Lymphatic capillaries. These are small thin-walled vessels lined by endothelium. Lacteals are specialized milky lymph capillaries found in the villi of intestines. These appear milky due to presence of fat. And what's their fat? It's chylomicrons, which they transport. Lymphatic vessels, they are formed by joining lymphatic capillaries. They resemble veins in having walls. They have thinner walls and numerous walls which give them beaded appearance. Then we have lymph nodes. Then lymph nodes, they are small, oval or bean-shaped bodies. They are act as filtrates. They also act as site of lymphocytic formation. They mainly line the neck, axilla, thorax, abdomen, and groin. The number is maximum in armpit and groin. It is contained in phagocytic WBC and macrophages which remove microorganisms and cellular debris. Lymph nodes destroy cancer cells. So what destroys cancer cells? Lymph nodes destroys cancer cells. They also make lymphocytes which form antibodies and provide immunity. Here we have circulatory system, important system of this whole chapter. Circulatory system, the functions of circulatory system are as follows. Transport of respiratory gases, transport of nutrients like glucose, amino acids, etc. Transport of nitrogenous waste like urea, uric acid, ammonia, etc. Transport of hormones, transport of intermediate metabolites like lactic acid, equal distribution of heat, homeothermy, transport of water and ions. These all are poured into the blood. Basically, it's the transport of blood. But what all are there in the blood, we have studied them. These all are being transported. Circulatory system means it's the pathway through which the blood travels. Types of circulatory system, we have open circulatory system, closed circulatory system. If we all know this open circulatory system, meaning it directly goes through the heart without any vessels, and through the body tissues it's again pumped out directly, but we know again. Found in leeches, mollusks, except cephalopods and octopus and arthropods. Blood does not remain confined to blood vessels, it comes out into open spaces, sinuses or channels lacunae. These sinuses join to form body cavities which is filled with blood and is called hemocoel. Anything sealed means cavity. The organs or tissues lie dipped in blood in these sinuses. Direct exchange of gases and substances take place between tissues and blood. In open circulatory system, blood flows at very low pressure and due to the absence of smooth muscles. If respiratory pigment is found, it is dissolved in plasma. There are no RBCs. Closed circulatory system, found in most annelids, earthworms, snails, cephalopods, mollusks, and all vertebrates. Blood always remains in close to blood vessels, arteries, veins, and capillaries. As the blood vessels have smooth muscles, blood flows at higher pressure due to their contraction and relaxation. No direct contact between blood and tissues. Exchange of material takes place between blood, in capillaries, and tissues in fluid, in inner cellular spaces. Closed circulatory system is more efficient in transporting material. By controlling the contraction and relaxation, volume of blood flowing through an organ can be regulated. We have circulatory system in human, so it's a closed type. It has three components: blood vessels, heart, blood, and lymph. Blood vessels, they are hollow tubular structure. Blood vessels are of three types: arteries, veins, and capillaries. Okay, comparison of arteries and veins. This is important. We always compare the veins and arteries, the major two blood vessels. Veins are thin-walled. Arteries are thick-walled. Like I told that time, arteries are thick-walled. Say, so are ascending limb of kidney. Okay, bring blood into the heart veins, carry blood away from the heart arteries. They invariably carry deoxygenated blood except pulmonary vein. They invariably carry oxygenated blood except pulmonary artery. Their wall is less elastic and they have wider lumen. Their wall is elastic in nature and they have narrow lumen. Arteries narrow lumen. They are superficially placed under the skin. They are deeply placed under the muscles except wrist, temple, and neck and ankle. Blood flows at very low pressure, so they have valves to prevent backward flow in veins, whereas in arteries, blood flows under pressure, so they do not have valves. Here we have the tunicas, meaning the histology of blood vessels. The tunica externa is more wider in vein compared to arteries. The tunica media is more wider in arteries compared to vein. Then we have the tunica and the elastic membrane, then endothelium, then lumen or tunica interna. Histology of blood vessels, wall of arteries made up of three layers. Tunica externa or tunica adventitia. Tunica externa is also known as tunica adventitia. It consists of collagen fibers to give strength to the blood vessels and prevent over dilation. It is more developed in veins as compared to arteries. Okay. Now tunica media. It is the middle layer formed of smooth muscles and network of elastic. Okay, what is it formed of? Smooth muscles. This is the question. The tunica media is formed of smooth muscles and network of elastic fibers. It is better developed in arteries and so the walls of arteries is more elastic. Tunica internal. It is the innermost layer formed of two parts endothelium. Innermost lining made up of flat elongated cells and the cells are joined edge to edge. They are more elongated in arteries. Elastic membrane. It is the outer layer of tunica interna formed of yellow fibrous tissue. Elastic. It is more developed in arteries. Then we have capillaries. They are the thinnest blood vessels, 10 micrometers in diameter. Each capillary is lined by a single layer of flat cells, endothelium. The endothelium allows the exchange of gas, substances and gases. Capillaries is a fun thing, like it's the main part where actually the oxygenated and deoxygenated blood passes through. In the capillaries, we get the exchange of oxygenated blood and deoxygenated blood. Then it enters into the veins and arteries. Veins and arteries are specified for certain things, but the capillaries is the only like the vessel part where both of them intertwine. But they don't mix. They're different, but they intertwine. Heart. It is a pumping organ that pumps blood, made up of cardiac vessels. Two types of heart. Myogenic, when impulse for contraction is generated by a special muscle, and neurogenic, when the brain or nervous tissue generates the stimulus for heart. One heart only, but only two types, two systems are taking the responsibility of its generation. On the basis of circulation also, heart can be single circulation heart or double circulation heart. Single circulation heart when the blood passes to the heart only once before being supplied to any part of the body, example fishes. Double circulation meaning when the blood passes through the heart twice before being circulated to any part of the body, example amphibians, reptiles, birds and owls. Structure of heart and different vertebrates. In fishes, they have two-chambered heart. It has two main chambers, auricle and ventricle, supporting chambers, sinuses, venosus and conus arteriosus. This is important. Supporting chambers are sinuses, venosus and sinuses, venosus and conus arteriosus. Sinuses, venosus is like our vena cava, whereas conus arteriosus is like our aorta, kind of, but not the same. They function the same. Sinus venosus and sinus arteriosus. Conus arteriosus. Sinus venosus, conus arteriosus. The heart of fishes receives only deoxygenated blood, so it is called venosus or branchial heart. It is a single circulation heart. Path of blood flow is heart, deoxygenated blood, gills, oxygenated blood, body, and again deoxygenated blood. Only deoxygenated blood passes through the heart. We have amphibians heart also, which is in detail. I'll only go through the first part. That is, they have three-chambered heart, two auricles, and one ventricle. They have incomplete double circulation because the blood gets mixed, and it's known as arteriovenous heart. Reptiles, 3 or 4 chamber we have. That is three or four chamber. Four chambered heart is found in crocodiles, alligators, and gavialis. Except for crocodiles, even alligators and gavialis have four chambered heart. We even have alligator as an example. So, in all other reptiles, interventricular septum is not fully formed. So only in these reptiles, interventricular septum is fully formed. Okay. Here also a heart is atriovenous, just like in amphibians, incomplete double circulation. Then birds and mammals, they have four-chambered heart, complete separation of oxygenated and deoxygenated blood. Sinus venosus has completely merged into right auricle. Then truncus arteriosus is evolved into one systematic and one pulmonary arc. Mammals have left systematic arc while birds have right systematic arc. What is left systematic and right systematic? The entry of blood. That is what they are talking about. Systemic here is the not entry, the passage, meaning from the left ventricle the blood goes through the aorta, then through aorta body parts. Whereas in the birds it's opposites. It's the right ventricle. Systemic circulation and pulmonary circulation. Two types of circulation. We have superior vena cava, inferior vena cava. Then we have pulmonary arc, we have aorta, systemic arc, which is also known as. And then we have pulmonary vein, then interventricular septum. The septum which divides the ventricles, auricles, both the things. That is interventricular septum. Between two ventricles is interventricular septum. Between two auricles is interauricular septum. Structure of mammalian heart, it's about 12 cm long and 9 cm wide. It is of the size of a clenched fist. It is mesodermal in origin. Mesodermal. Average weight is of 280 to 340 grams in males and 230 to 280 grams in females. Externally, two grooves can be seen: atrioventricular groove or coronary sulcus. It separates heart into upper thinner and softer part called auricular part, and posterior larger, thicker and hard ventricular part. Interventricular groove, it separates right and left ventricle. Atrioventricular groove and interventricular groove. What we studied first was interventricular groove or interventricular septum. That separates two right and left ventricles, but whereas atrioventricular septum is like this part. It separates the upper part, the right atria and left atria from the ventricles, the thick part. Ventricles are thick compared to atria or atria. The heart is surrounded by double-layered pericardium. The inner membrane is called visceral membrane and the outer is called the parietal membrane. Between the two membranes is the filled pericardial fluid. Approx is 15 ml of pericardial fluid. Approx. Pericardial fluid acts as lubricant and protects the heart from mechanical shocks. Auricles are the receiving compartments, and the right auricle and the left auricle are separated by interauricular septum. So it exists. Right auricle receives deoxygenated blood through superior and inferior vena cava and coronary sinuses. Coronary sinus is one present in heart. When heart needs to be oxygenated and deoxygenated when it has that. Left auricle receives oxygenated blood from lungs through 4 pulmonary veins. Valve of inferior vena cava, valve of case chin, believed to be the remain of sinus venosus. Valve of eustachian, valve of coronary sinuses, valve of Thebesian. No valves in pulmonary veins and superior vena cava. Valves in heart were first reported by Fabricius. Auricles have smooth inner walls except a low network of ridges called musculi pectinati. An opening in interauricular septum found in fetal stage is called foramen oval. This is important. Foramen oval, during when the embryonic development of a baby, the heart has this passage known as foramen oval, and once it's out to the world. This foramen oval should be closed, meaning it gets closed after the developing of cardiac muscle, and it stays with a mark over there, and that is known as what magnet was that? Fossa vallis. Fossa vallis is the mark which stays over there in the heart of all. Okay, so the opening closes at birth, but the scar is seen, which is known as fenestrovallis or fossa vallis. Both are same. So, but sometimes this opening does not close, and the condition is called hole in the heart. Okay, blue babies, septal defect due to non-closure of foramen ovale. Foramen ovale leading to mixing of blood. So this is really a serious case. The blood should never get mixed, especially in mammals, because they are homeotherapy, meaning they must regulate the blood temperature. And mixing of blood, the first default thing, meaning what goes wrong with the mixing of blood is temperature. The temperature of the body goes, the pH of the body goes, everything goes. That's it. Including the materials like PC glucose, proteins and all, they get intermingled. Right auricle and left auricle pour the blood into the respective ventricles. The opening of auricles into ventricles is guarded by veils. Veils help to maintain unidirectional flow. Left atrioventricular veil is called bicuspid or mitral veil. It has two semicircular cusps. Right atrioventricular veil is tricuspid veil. It has three cusps. Okay, both ventricles have rough inner walls. They have two types of ridges. Low networks and well-developed ridges are papillates. Left ventricular wall is 3 times thicker than the wall of right ventricle, as left ventricle has to pump the blood to all body parts and the right one has to pump only to lungs. Chordae tendineae are attached to papillary muscles and on underside of the cusps of AV veins. They prevent backward movement of the cusps of AV veins. Our right ventricular pumps the deoxygenated blood to the lungs through the pulmonary artery, and LV pumps oxygenated blood to the body parts through aorta. Opening of pulmonary artery and aorta have semilunar veins, that is tricuspid, to prevent backward flow of blood. Foramen of Panizzi, opening between two systematic arches in reptiles. Okay, then duct of Botany. Origin and conduction of heartbeat. This is important. How it's originated and how it's conducted. Initiation and conduction of heartbeat is under the control of 3 special muscular bundles or nodal tissue. As the impulse originates in a muscle, mammalian heart is called myogenic or autorhythmic heart. Ringer's solution. When heart is placed in Ringer's solution, it goes on beating for some time. This confirms that heart is myogenic. Ringer's solution is a physiological saline solution which contains salt of sodium and potassium. What these do? They contain electricity. That's why the heart starts beating. The conducting system comprises of SA node, sinoatrial node, Kate node, discovered by Sir Arthur Kate and Martin Black. It lies in the right wall of right auricle below the opening of superior vena cava and is called right-sided structure. It represents the remain of sinus venosus. SA node generates the action potential 70 to 75 times per minute and is responsible for initiating rhythmic contractions of heart, and so is called the natural pacemaker. This is important. Right atrium, very top corner of the right atrium is where sinus is present. Sinoatrial. The impulse travels at the rate of 1 meter per second on 2 auricles. This impulse reaches from SA node to AV node, atrioventricular node, AVs, in 0.3 seconds, but cannot pass through the ventricles because the muscle fibers of auricles and ventricles are separated by a thin layer of fat called annular pad. Okay, as impulse originates at SA node, auricular systole precedes ventricular systole. Systole means contraction, diastole means relaxation. Key terms. Okay, SA node has highest degree of autorhythmicity but least conductivity. AV node or auriculoventricular node, pace center, lies on the right atrium near the junction of inter-auriculoventricular septum close to the opening of coronary sinus. AV node was discovered by his scientist name is His. It conducts the impulse from SA node to bundle of His at the rate of 1.5 to 4 meters per second. Bundle of His. After AV node, we get the AV bundle, or which is also known as bundle of His. Arises from AV node, enters into interventricular septum and divides into right and left branches. The two branches conduct the impulse into the walls of ventricles by a network of Purkinje fibers. Purkinje fibers is the only ventricular part. Only in ventricles we can see this. If SA node is damaged, the heart becomes irregular. This condition is called arrhythmia and may require an artificial pacemaker. Yeah, there is like a surgery done to attach an artificial pacemaker. That was once a question in some module they asked. Oh, in the condition of arrhythmia, where would the new pacemaker be attached? Basically, it's the same place only, the sign of atrial node. But originally that's not the case. In the practical case, it's not. Cardiac cycle. The conducting system. It is completed in 0.8 seconds. The cardiac cycle 0.8 seconds is completed. One cardiac cycle. It includes the systolic phase and the diastolic phase. Systolic, diastolic, same, contraction and relaxation. The cardiac cycle can be studied under the following heads: atriosystole, ventricular systole, joint diastole. Here we have to know because it's the sounds are there. Atrial the auricles contract. The right auricle contracts first. The blood from the auricles is pumped into the respective ventricles. It is completed in 0.1 seconds. After systoles, the auricles enter into diastolic phases. Ventricular systole. The ventricular contraction results in the pumping of blood into the main arteries. The blood from the right ventricle is pumped into the pulmonary artery and from the left ventricle into aorta. To prevent the backward flow of blood into the auricles left and right, atrioventricular walls close, making a sharp sound lub. This is the first sound. So what are these walls? Sounding of tricuspid and bicuspid waves gives us the sound lub. The first sound is called systolic sound. It is louder and for longer period of approx of 0.14 seconds. So the longer period is nothing but 0.14 seconds. Ventricular systole is completed in 0.3 seconds. During ventricular systoles, the auricles remain in diastole. After the systolic phase, the ventricles enter diastole. Anything after systolic enters diastole. Joint diastole. After ventricular systole, the ventriculars also relax and the auricles are already in diastole. So at this stage, all the four chambers of the heart are relaxed. This is called joint diastole. During this phase, as ventricles are relaxed and empty, to prevent the backward flow of blood from pulmonary artery and aorta into the ventricles, the semilunar valves close, making the second heart sound dubbed. Second heart sound is called diastolic sound. It is less loud and is for shorter period, like 0.11 seconds. During auricular diastole, the pulmonary veins and superior, inferior vena cava and coronary sinus keep pouring blood into the auricles. End of diastolic volume, about 110 to 120 ml of volume of blood is relaxed in ventricles at the end of arterial systole. End of systolic volume, about 40 to 50 ml of blood in ventricles at the end of maximum ventricular contraction is given out. These ratios which I am telling, that much amount of blood is given out. One cardiac cycle is completed in 0.8 seconds and the breakup of auricular and ventricular systolic and diastolic time is as under. It's broken down into the time of how much one auricle takes, how much one ventricle takes. Okay, fine. Stroke volume, like we all know the volume of blood pumped out by left ventricle per beat. Stroke volume is 70 ml of blood. Okay, cardiac output. We get the cardiac output by anything. They give any cardiac output calculations by stroke volume into heart rate. Heart rate is fixed 72 times per minute. Stroke volume we know 70 ml. So it's 5 liters, but according to the case, we can do the calculations. Stroke volume into heart equals to cardiac output. Sometimes they give cardiac output as stroke volume and tell us to find the heart rate. Do that simple math. Types of circulation: systemic circulation, circulation to and fro from the body parts. In this, the blood completes its circulation from left ventricle to right auricle through body organs. Pulmonary circulation, the circulation to and from lungs. Then this blood completes the circulation from right ventricle to the left auricle through the lungs. Now control of heart. This is another important topic. Okay, we have 1, 2, 3, 4, 5 more pages then done. Wait for a while. Control of heartbeat. So first control, we even have nervous control. Apart from nodal tissue. So nodal tissue also what it does, it controls only. No, it's not like it's not controlling because the lub and dub sound is produced by nodal tissue. But except from nodal tissue, what is there? Another conducting system. Okay, it's also controlled by nervous system as well as hormonal system. Nervous control. 2 cardiovascular centers are located on the ventral wall of medulla oblongata. Medulla oblongata is the brain. Okay. Cardiac axillary center. It is associated with sympathetic nervous system. This center dominates during exercise. It increases the rate of heartbeat up to 200 to 250 times per minute and depth of the heartbeat up to the 2 folds. This is reported by Otto Lowenby. It accelerates the heartbeat by increasing the secretion of neurotransmitter called adrenaline, also called epinephrine. Cardiac inhibitory center. That was acceleratory, meaning the one which generates the beats. Now it reduces the beats is inhibitory center. It is under the control of parasympathetic nervous system. The center dominates during sleep. Okay. It decreases the rate of heartbeat up to 20 to 30 times per minute and depth up to 20% to 30%. Okay, the neurotransmitter is acetylcholine. Hormonal control. The hormones which regulate the heartbeat are epinephrine and norepinephrine. Both the hormones are secreted by adrenal medulla of the adrenal gland. Both increase the rate of the heartbeat. Epinephrine increases the rate of the heartbeat during emergency. Norepinephrine increases the heart rate beat under normal condition. Blood pressure. Arterial blood pressure can be defined as the pressure exerted by the blood on the blood vessels in which it is present. The instruments used to measure this is sphygmomanometer. It was invented by Korotkov in 1905. In this, the blood pressure is measured in terms of air pressure. This is called oscillatory method and is an indirect method of measuring blood pressure. Indirect method, not direct. BP is represented as systolic pressure per diastolic pressure and the unit is mm of Hg. Systolic means contraction pressure per relaxation pressure. Atrial blood pressure is of 2 types. Systolic blood pressure SBP. It is the pressure exerted by blood on the wall of blood vessels at the end of ventricular systole. In a normal healthy adult, SBP is about 120 mm of Hg. Then we have diastolic blood pressure. It is the pressure exerted by the blood on the wall of blood vessels when the ventricles are maximally relaxed. In a normally healthy adult under resting condition, it is about 80 mm of Hg. Okay, so the blood pressure increases with age. In a newly born baby, it is about 90 per 55 mm of Hg. In a young adult, it is about 120 per 80 mm of Hg. In old age, it is about 150 per 90 mm of Hg. With age, the blood vessels lose their elasticity. This also results in high blood pressure. Calcium deposition in blood vessels lead to arteriosclerosis. This is really bad. Arteriosclerosis. This can lead to heart disease. Here, viscosity of blood also increases with age. Viscosity means slimy substance. This results in total peripheral resistance and high BP. The other factors which result in the increase in BP are exercise, tension, fear, anxiety and depression, etc. ECG, also written as EKG, is electrocardiography. Electrocardiography is a machine used to record the electrical activities of the heart. Electrocardiogram is a graphical representation of the activity of the heart during a period of time using electrodes placed on the skin. These electrodes detect the electrical changes that arise from heart muscles during depolarization and repolarization. ECG was discovered by Enthuvan, but the first ECG was recorded by Valor. Okay, leads from an electrocardiographs are attached to arms, leg, and chest. These leads are read signals from the heart and recorded it on paper. But according to NCT, we have the leads attached to right wrist, left wrist, and the left ankle. That's it. Feet one. No, nothing more. Like the chest region and all, it's not specified according to NCT. ECG can be taken in lying down position known as resting ECG and during exercise known as stress ECG. Okay, this is how a typical ECG looks like. Everyone knows like the PR interval, the PR segment, then QRS complex, QT, ST segment, then the QT interval. ECG for heart of a normal healthy person. Whatever I told, I'll tell what it is. P wave is excitation or depolarization of atria or auricles, impulse of contraction generated by SA node, resulting in contraction systole of both atria. And PQ interval is of 0.1 second, atrial contraction. Then we have QRS complex, depolarization of ventricles, spread of impulse to ventricles. RS and ST, ventricular contraction. T wave, repolarization of ventricles, ventricular diastole. PQ is atrial contraction. QRS complex depolarization of ventricles. RS and ST ventricular contraction. T wave repolarization of ventricles, ventricular diastole. P, R and T waves are called positive waves and Q and S are negative waves. End of T represents end of systole. Q represents start of systole. Pulse, a wave of pulse. Portal system. In the portal system, we have this hepatic portal system. Hepatic portal vein collects the blood from alimentary canal and divides into a second set of capillaries into liver, intermediate organ. In liver, the hepatic portal vein offloads substances like glucose, amino acids, fats, etc. Significance of hepatic portal system is that it helps offloading the substances in liver where they will be used or converted, like liver regulates glucose level by glycogenesis and glycogenolysis. So it removes harmful amino acids by deamination and detoxification. It also releases heparin, fibrinogen, prothrombin, vitamin A and vitamin K. That is one which we all have studied, hepatic portal system. We don't have renal portal disorders of circulatory system, and with that we are ending this session. So the last thing is the disorders of circulatory systems. Take only like five more minutes then. Hypertension, high blood pressure. It is a condition when BP is higher than normal, more than 140. High BP leads to heart disease and also affects vital organs like brain and kidney. Coronary artery disease, CAD, often referred to as atherosclerosis. Atherosclerosis and atherosclerosis are two different things. Atherosclerosis, atherosclerosis. Due to deposition of calcium, fats, cholesterol, and fibrous tissues which make lumen of blood vessels narrow, meaning the blood can't pass through the blood vessels. Angina or angina, also called angina pectoris. Symptoms: acute chest pain due to not enough supply of blood to heart muscles, more common among middle-aged people and elderly. Then we have heart failure, state of heart when it is not pumping blood effectively to meet the needs of the body. It is also known as congestive heart failure. Okay, and cardiac arrest is something when the heart suddenly stops beating, that is cardiac arrest. This is heart failure. Then we even have heart attack. Heart attack is the sudden coagulation of the blood vessels. That is the heart attack. When the heart stops beating due to the coagulation. Certain coiled blood vessels. The blood doesn't pass through the blood vessels. Heart is the busiest organ. Study of blood vessels is known as angiology. That is one more thing. Then heart pumps about 7,000 liters of blood per day. There are certain facts to know, like the first heart transplant. Marcelo Malfigi even discovered blood capillaries. Okay, with that we end this session. I hope this was a long session and it was a good one because we went through many of the bio concepts, breathing and exchange of gases, very important chapter. After that only it comes the fluid to body fluids and circulations. But first we went through the excretory products. Right? We went through the excretory products and their elimination. Yeah. The process is breathing and exchange of gases, excretory products and their elimination, body fluids and circulations. We covered all the 3 major chapters and all the in the excretory half only half was done for us, so I covered half. Next half I'll cover once it's over. I hope you all had amazing time. I hope it was really active session. I talked a lot. Normally I don't. Bye bye. See you. Good night. And just have your dinner. Well.